Hello, hi, namaskar everyone. Give me a quick response if I'm clearly visible and audible. I hope you all can hear me, you all can see me. I hope the stream is running smoothly. And if it is all going fine, just give me a quick thumbs up in the chat box so that we can straight away get started. So I hope you all can hear me, you all can see me. Just give me a quick response. Everybody, am I clearly visible? Am I clearly audible? Great, great, excellent. With that, good evening, good evening, good evening. Namaskar everyone. We are getting started with today's one shot for all the 11th class students. They can clearly see written on the board, which is our very own chapter, Trigonometric Functions. You must have learned a lot of identities, ratios in 10th standard or till 10th standard. T ratios or trigonometric ratios, we call them sine, cos, tan, cosec, sec, cot. And some basic 3 standard identities you must have learned, which are sine square theta plus cos square theta is 1 plus tan square theta, and 1 plus cot square theta. I hope these 3 very crucial one, based on which you must have done a lot of modifications and created a lot of more formulae and identities. The same thing gets extended in 11th standard, and there also we do a lot of identities. So in 10th standard, if you were restricted till 3 core identities, in 11th standard, the width and depth both get introduced. So you may get minimum or at least 30 core identities. I'm saying core. Definitely Laksh, anybody from English, if can understand Hindi, definitely watch this video. So shall we get started, everyone? Good to have you all. Good to have you all. Good evening, everyone. Hi, namaskar. We are getting started with this session, Trigonometric Functions for all the class 11 students. Shall we, everyone? So what are we going to cover today? Before I tell you that, if you are participating today in the polls, you all can participate by downloading PyLens application. It is simply a platform and an application which you can download from Google Play Store, with the help of which you can participate in the polls. So to mainly participate in the polls, do we really have to download an application? Absolutely not. It is not just for participation in the polls, but let's say you're watching any random video on YouTube, a non-PW video also on YouTube, and you want to generate short notes on it. You want to get previous year's questions on that topic. You want a crisp, summary on it. You want mind map on it. Whatever related to that video can be generated with the help of PyLens application. So you can download it from either Google Play Store or Chrome Store if you're watching it on the desktop or laptop in the browser. I hope you all can hear me, see me, and we can get started with our discussion on Trigo. Before Trigo, we have done some basics. Basics means sets and relations and functions for class 11th. Today, the same series is getting extended. This is an absolutely free batch, which we have rolled for you all. You can see the link of this free batch in the description. Sir, if we can watch it on YouTube, why do we click on any link, any external link? Because after this session, the entire PDF of this one shot of trigonometric functions for your board's preparation will get uploaded on our application. So the link which is pinned comment or given in the description will take you to our free batch where you'll get this PDF. So to get merely again a PDF, do we have to enroll? First of all, enrollment is free. And along with that enrollment, you get 24/7 doubt support mechanism, a system. Let's say you get stuck at 2 o'clock night and you want to ask a doubt. We will handle your doubts, even at midnight, 2 o'clock. Yes. So we are getting started with our discussion. I hope today, what are we going to discuss? First of all, we'll start with trigonometric ratios. So we'll cover those ratios and then we'll understand the conversion. Conversion means degree, radian and all. And then we'll talk about a lot of formulae. Sir, formulae means what? Formulae means there are a lot of identities. And once we are done with trigonometric ratios, formulae and identities, trigonometric functions we call them, gradually we'll move towards trigonometric equations as well. So trigonometric equation based questions as well will solve. And I'll definitely tell you the difference between an identity and an equation. You will definitely learn that as well. Is that it, sir? Yes, that will be sufficient for your boards, but it is not just 4 things which I've written over here. It is huge. So we'll be covering it all in this one short video of trigonometric functions. So we are straight away getting started, everyone. I hope you all can listen to me, see me. First of all, trigo, where does it come from? So I hope you must have studied this thing clearly in 10th standard that, sir, if you see a right angle triangle and if you define an angle like this, let's say this is theta. So this side is called perpendicular. This side with respect to this theta is called base, adjacent side, opposite side. And this, the side which is the lengthiest side in a right angle triangle is called hypotenuse. And the observation which is made here, not just a Pythagoras theorem, but if the angle is fixed, which means if any triangle if you take by using proportionality or by using similarity, we can clearly see that these ratios perpendicular upon base, perpendicular upon height, perpendicular upon hypotenuse, base upon hypotenuse, these ratios, if this theta is fixed, no matter for whatever right angle triangle you take, if this theta is the same there as well, you will see the ratios to be same. So that advantage we took. So if we took that advantage, we could conclude that sine theta, what is sine? Sine is a ratio. Ratio of what? This theta angle. So this theta sine ratio means perpendicular and hypotenuse ratio. So this is given by perpendicular and hypotenuse. I hope this is very basic, easy, direct. So we are starting from that scratch. I hope you can see that right there in front of you. When we talk about cosine ratio, so this is written as cos theta, cosine ratio, that is clearly given by adjacent upon hypotenuse, that's base upon hypotenuse. And similarly, I don't have to tell you, when we talk about tangent, which is tan theta, it is given by perpendicular upon base, which is clearly P upon B. So I hope everybody clearly noticing that says sine and cos, if you divide, hypotenuse gets cancelled and you again get P upon B. So tan theta is actually sine theta upon cos theta as well. Not just that, there are reciprocals as well. Reciprocal means what? If you have sine theta, its reciprocal is cosine. I hope cosine is actually cosec. So cosec theta is here, h upon P. I hope you're understanding it. Similarly, if there is cos, its reciprocal is sec. So here it is given by sec theta, which is h upon B. And there if you have tan, its reciprocal is given by cotangent, which is cot. So cot theta is its reciprocal, which is given by B upon P. Any queries, confusions? I hope this is easy, direct, straightforward. Now Pythagoras suggested you something very beautiful. Sir, what did he suggest? He gave you that for any right angle triangle, perpendicular square plus base square is hypotenuse square. Yes or no? Sir, what if we divide both these sides by h square? Okay, let's do that. So if I divide both these sides by h square, what result do we obtain? It will be P by h whole square. This will be B by h whole square. And this will be h by h whole square, which is 1. Now, can you help me with P by h, perpendicular upon hypotenuse? That's sine. So this will be sine square theta. Base upon hypotenuse, that's cos. So this is cos square theta. And this is equal to 1. What does it mean? This here means that sine square theta plus cos square theta is always 1. Is always 1. Is always 1 means it is always 1 for any real value of theta you take. 30 degree, 45 degree, 75 degree, 8.2 degree, 9.7 degree, any theta you take, 1000 degree, 1003 degree, any angle you take, if you push it there, it will be 1. So is it an equation? No, it's not an equation, it's an identity. Are you learning the difference between an equation and identity? For example, if I were to solve an equation, x square is equals to 1, so here I'll get solutions. So this is an equation. Equation means equations has roots, it has solutions. So it is not satisfied by all the values of x. It is satisfied by some specific values of x. X being 1 or x being minus 1 will satisfy it. So that's an equation. So what is an identity? Sir, identity would mean that it will be satisfied by all the values of theta which are acceptable. Here in this case, theta can be any real number. So sine square theta plus cos square theta is always 1, no matter what theta is. So that's why we say this is not an equation, this is an identity. Everybody getting this point comfortably, all the participants. I hope you got it. Similarly, if I divide it by b square, both sides, if I divide by p square both sides, I get two more identities, which you all must have learned are 1 plus tan square theta, which I hope you know is sec square theta. And if I do 1 plus cot square theta, that I hope you know is cosec square theta. So these two more identities you clearly know. I believe so. Sir, why do you believe this? Because this is what you all must have already studied in 10th standard. Nothing new about it, right? So there is nothing new we have done. Okay, sir, then what does it mean? Here in 11th, first of all, one very interesting thing gets introduced, that let's say you have an initial side. This is the initial line, initial position we can call it. And then there is this final position. So let's say this is the initial position and this is the final position. So sir, what is technically an angle? Angle is basically measurement of inclination of a line with respect to other line. So if I have a line in its initial position like this, I rotate it by certain degrees, let's say theta, in anti-clockwise direction. What direction it is? Sir, this is anti-clockwise direction. Sir, how are you deciding anti-clockwise or clockwise? I can see it can be clockwise. No. I am directly and definitely and surely calling it anti-clockwise because this is the initial position. And from initial, I am going to the final position by rotating it into anti-clockwise direction. Can you read it? So, sir, what is the point of anti-clockwise or clockwise? Theta is theta. Theta is theta in terms of magnitude. Numerically, it is theta. But if it is anti-clockwise, it is read positively. If it is clockwise, it is read negatively. Sir, what did you just say? I said that if this movement is 30 degree, let's say for a while, then yes, it is plus 30 degree. But let's assume for a while that this is initial position and this is final position. Now, can you help me with the movement this time? Sir, initial to final, we are moving in clockwise direction. So if the movement happens in the clockwise direction, angle is read negatively. So here, let's say the magnitude wise, the angle is 30 degree, but direction, if also included, this angle over here will not be 30, it will be minus 30 degree. First of all, let me know honestly, did you all understand this point? Did you all get this? The difference that when you move from in the anti-clockwise direction, angle is read positively. If you move in the clockwise direction, angle is read negatively. Everybody with me so far? Okay, sir, we get it. Then what is the use of it? Use we'll discuss later when we talk about quadrant theory. But right now, I want you all to understand the relation between degree and radian. I hope some of you already know this, the relation between degree and radian, don't you? I hope you do know it, everyone, all the participants. So first of all, let's understand degree in more clear manner. Degree is denoted by 1 degree, this small hollow circle. And 1 degree, if I ask you, in minutes, it is 60 minutes. 60 minutes means 60 dash. This dash sign is reserved for minutes. So if 1 degree is divided into 60 equal parts, one of those equal parts will be 1 minute. So 1 degree in terms of minutes is 60 minutes. And if I ask you 1 minute, so it will be 60 seconds, and seconds are denoted by double dash. I mean, if that 1 degree is divided into 60 equal parts, then one of those parts will be minute. And if that 1 minute is divided further into 60 equal parts, that will be 1 second. Out of those 60 equal parts, that will be 1 second. Can you visualize it? Can you imagine this? All the participants. Everybody with me so far? Any queries, any concerns? If you have, keep your doubts posted in the comments. I'd love to clarify those. Shall we move further from here? Okay, sir, we get degree in minutes and seconds, everything. What else? Here, let's say if I ask you 180 degree. Okay, let's forget 180 degree. Let us try and define 1 radian. So, sir, what is the meaning of 1 radian? Imagine there is a circle. Imagine there is a circle. And this circle has a certain radius r, small r. Now, equal to the length of its radius it's double dash, equal to the length of its radius if I measure an arc on its perimeter or circumference. So I'm measuring an arc over here. Let's say this is that arc, this is that arc, this here is that arc, which let's say has the same length as its radius for a while. Let's say this and this are same. This length of the radius and this length of the arc are same. Both are r, small r. So there, if I ask you to measure the angle subtended over here, what would that angle be? Can you help me with that angle? Anyone? I hope you all must have studied this formula that if there is an arc which is having length L and this arc, let's say, subtends an angle theta on the center of the circle, then that theta is given by length of the arc divided by radius of that circle. Have you all remembered or understood or learnt this formula already? Yes or no? Then in that case, here comes the next result, which is theta is equal to, if I take this length of the arc equal to the length of the radius. What did I just say? I repeat. Here, length of the arc. Excellent, Vijay. Keep it up. Length of the arc, if I take equal to its radius. So L becomes R. So if L becomes R, this is R by R and theta becomes 1. Now, is it 1 degree or 1 radian? This formula, if you have studied, this formula actually gives you theta in terms of radian, not in degrees. So if you were doing it so far or using it so far like this, the theta which you have been receiving so far was not in degrees, it was in radians. So let us correct it today. If the radius and the length of the arc are same, then that arc equal to the length which is equal to the radius of the circle will subtend an angle at the center of the circle which will be 1 radian. 1 grade you will convert it into 100. It was, I think, developed by European or French people, and it did not get very famous technically because the problem was 60 was a more beautiful number because it was divisible by a lot of numbers. It has a lot of factors like 2, 3, 5, 12, and because of that 60 got more popular. So we are still using that degree or radian conversion. So grade did not get so popular, like they divided 1 degree into 100 grades and all like that, and that's where they did not find it much useful. Even I don't remember it correctly. I think 1 degree is 100 grade or 1 grade is 100 degrees. That you need to verify. Can somebody tell me in the comments, by the way? So I come back to it. What you need is degree and radian. Grade is obsolete actually. It got outdated. So I am clearly saying that here this theta is not 1 degree, it is 1 radian. And radian also has a unit. For example, degree is denoted by this dot, radian is given by C. So let's say if I ever measure an angle and if I tell that this is sine 20, so please don't take it as sine 20 degree. There is a difference that this is sine 20 and this is sine 20 degree. So for degree, I'll specifically put this dot. But for radian, I'll put either sine 20 like this or I'll say sine 20 radian. For radian, there is a small c here. Everybody got this part? Any queries or confusions if you have, please ask. I said two things very clearly. If you are having radians, for radians, we don't write any unit at all. So if you are not writing any unit on an angle, that is by default radian. It's not degrees, of course. Or if you are specifically putting a C, that is clearly radian. So if I ever mention to put a degree, that will be technically a radian. Beautiful, 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 beautiful. Excellent. I hope everybody with me so far. Any queries or confusions if you have, please ask. Yes or no, all the participants. There comes the next thing where we talk about 1 radian, I hope everybody has understood. Now, if I extend this idea further, of radian, and if I take it with or compare it with the idea of degrees, what does it mean? Let's talk about that result as well. Everybody, please pay attention. I hope you do agree that, sir, if you rotate it by 180 degree, where the circle has radius r. So what do you mean by 180 degree? Sir, 180 degree here would mean that this will be the length of the arc. So this length of the arc, which is L upon R. But what is this length, sir? I hope you do remember, for a circle, the total circumference is 2 pi r. But this is actually semicircle, so it will be pi r. So here in this case, L becomes pi r. So if L becomes pi r, in this case, it will be pi r by r. So r and r are cancelled. I'm left with pi. Did you all get this? What did I just say? I said that this semicircle over here, which is having a length pi r in terms of arc, there, this arc, which is a semicircle, which is having length pi r, will subtend an angle pi radian on its center. Yes or no? Everybody getting it? All the participants. So what did I just say? I said that here 180 degree we have cracked as pi radian. Something very beautiful and important we have developed, that 180 degree is pi radian, and with this relation we'll work out all the other conversions as well. Everybody got this conclusion first of all? Yes or no? So sir, we have concluded this idea that 180 degree is pi radian. 180 degree is pi radian, yes. Half of 180 is 90. So half of pi is pi by 2. Half of 90 is clearly 45. Half of pi by 2 is pi by 4. Yes or no? 1/3 of 180 is 60. 1/3 of pi is pi by 3. Half of 60 is 30. And half of pi by 3 is pi by 3 by 2, which is pi by 6. These are some standard angles which you should be aware of. But sir, are we really going to remember all of these like this? Absolutely not. Something very basic, which you all must have already done in 5th or 6th standard, which you all must have learnt in 5th and 6th standard, is needed to be done. Sir, what is that? Unitary method, do you remember that? If 5 apples cost you 10 rupees, then 1 apple will cost you these many rupees, then 15 apples will cost you these many rupees. That basic idea. So whatever angle I give you in terms of either degree or radian, can you not convert it into radian or degree respectively? Sir, how? Look at this basic idea which we have developed. 180 degree is pi radian. Look at this. Can you tell me what will be 120 degree in the comments very quickly? 120 degree students, very quickly. 150 degree then. Quickly, be quick. Can you tell me what will be 2 pi? Can you tell me what will be 3 pi by 2? Be quick, students. Very basic questions I'm asking. What am I asking you here is, first of all, my first question was that can you convert 120 degree? Okay, sir, 120 degree is what you're asking. Yes, I'm asking you to convert 120 degree. So how do you convert 120 degree, students? Into radians. So the idea is really simple. 180 degrees pi. So 1 degree will be pi by 180 radian. What are you asking? I'm asking you 120 degree. So 120 degree will be 120 pi by 180. Yes or no? I hope that's easy. 6 into 2, 6 into 3. That's clearly 2 pi by 3. I hope that was easy. Good. Excellent. That's brilliant. Good, students. That's good, Vijay. Excellent. Similarly, what if I ask you, I think I asked you 150 degree as well. So I hope now you must have cracked the idea. Simply multiply that degree by pi by 180. So for 150 degree, it will be 150 into pi by 180. Yes or no? So there I think 3 works fine. 3 into 5, 3 into 6. Correct me if I'm wrong. So 3 into 5 is 15. 3 into 6 is 18. So 150 degree will be 5 pi by 6. I hope that's easy, direct, straightforward. That's good. Krishna, excellent. Similarly, I think I asked you a few more results. For example, I think I asked you 2 pi. So I think that's even easy because sir, pi radian is 180 degree. So 2 pi will be 2 into 180 degree. That's how much? That's 360 degree. I think I asked you 3 pi by 2. So for 3 pi by 2, what will you do? 3 into pi. Pi is 180 by 2. So how much is that? 19 to 3. That's clearly 270 degree. Isn't it simple, direct, easy and straightforward, all the students? Yes or no? Good, good, Vijay. That's excellent. Keep it up. I hope it was all simple. So now I am believing that you understand degree and radians conversion directly. Yes or no? Okay. So we got it. Then we have trigonometric functions. What are they exactly? So trigonometric functions are your straightforward functions like sine, cos, tan, cosec, sec, cot. These are the standard core 6 functions which you follow. Let's understand them one after another. So these 6 ones I'll explain to you one after another. So I'll begin with sin x. So let's say if I'm given sin x. So how does its graph look like? I'll show it to you so that you don't just have to believe me blindly. You can also see it happening. So I'll just demonstrate it to you so that you don't worry about it. Give me a moment, everyone. So I hope you all can see it very clearly. Everybody paying attention. So let's say if I were to draw y is equal to sin x, right? This is your curve y is equals to sin x. Look at this. Look at this. Y is equals to sin x, everybody. So here I hope you do notice this is a curve which clearly fluctuates between -1 and 1. And this is exactly how it keeps going. It keeps going. It stays clearly between -1 and 1. It stays between -1 and 1. And it just keeps going like that. So I hope you all have sufficient and valid reason to believe that yes, sin x indeed looks like this. So in a nutshell, in a rough manner, if I could draw sin x for you, the graph goes like this. The graph goes like this. The graph keeps on going like this. This is how sin x in a rough manner looks like. Absolutely, absolutely. Good, great, excellent. Now, if we make few more observations, sir, what are those observations? First of all, you will see its existence on the y-axis from -1 to 1. And on the axis, you will see the graph is continuously deployed between -infinity to infinity. So I hope in relations and functions, we did understand the concept of domain and range, didn't we? So I hope you remember all the values of x which I can put here are the domain. So x can take any real value. And all the values sin x can take, will be the range, which means that sin x we can clearly notice is, roaming between -1 and 1. So its range is going to be -1 to 1. Few more really crucial and important observations if you could make. Those are sine is 0 at 0, 0 at pi, 0 at 2 pi, 0 at 3 pi, 0 at -pi, and so on. So whenever somebody asks you that if sine x is 0, you generalize that x will be n pi, where n is an integer. Good, Vijay. Excellent. What did I just say? I said if sine x is 0, x will be pi, 2 pi, 3 pi, 4 pi, 5 pi. So it will be of n pi. Excellent, excellent, Krishna. Keep it up. Similarly, what if I ask you that, sir, sin x is 1. So when do you see sin x to be 1? Sir, here exactly between 0 and pi, there will be pi by 2. This will be 3 pi by 2. This will be 5 pi by 2. This will be 7 pi by 2 and so on. So sir, sin x is found to be 1 specifically at pi by 2. Then at 3 pi by 2, no. At 5 pi by 2, yes. So imagine this, 1 into pi by 2. 5 into pi by 2. So it's like 1, 5, 9, 1, 5, 9. They all are 1 more than the multiple of 4. Yes, which means sin x is 1 whenever x is 4n plus 1 times pi by 2, where n is nothing but an integer again. So I'll not write it repeatedly. We'll assume it now that n is an integer. Did I make it really difficult? Were you all able to understand this point? Yes or no, all the participants? Absolutely, absolutely. It's not 2, it's 1, Vijay. I think you have mistakenly written it. No worries. One more conclusion, if I could ask you, what is that? If I ask you that if somebody says that sir sin x is minus 1, then what do you conclude? So sin x is minus 1. The remaining odd multiples of pi by 2, like 3 pi by 2, 7 pi by 2, 11 pi by 2, 15 pi by 2, these multiples of pi by 2 will give me minus 1. So process this idea. 3 into pi by 2, 7 into pi by 2, 11 into pi by 2, 3, 7, 11. Are they not 1 less than the multiples of 4? So how will I write it? Sir, if sin x is said to be minus 1, I'll say x will be 4n minus 1 times pi by 2, where n is nothing but what? An integer. Did you all get this result? Did you all understand this result clearly, all the participants? Along with this, one more idea you should remember here is that, sir, if you notice that sin x is symmetrical in the opposite quadrants. Whatever behavior it shows here, the same symmetry or reflection it shows here with respect to origin. Which means if a curve or a graph is symmetrical with respect to origin in opposite quadrants, we call it an odd function. Sir, what do you mean by odd function? Odd function here means that f of minus x will be minus of f of x. Sir, what did you just say? I said that sine of minus x will be minus of sine x. Let's say if I'm trying to figure out sine minus 45 degree, I'll say minus sine 45 degree will be same. Everybody processing this idea comfortably, all the participants. Any queries or confusions if you have so far, please ask. Can I move further from here? Did you all understand everything regarding sin x? Any confusion? In the same manner, let us move ahead with cos x. Now let us try and define the curve cos x. Everybody. The way sin x behaves, in the same manner, cos x also behaves, but with a slight change. So what is that slight change? That slight change is that this curve now just shifts by pi by 2 on the left hand side along with the x-axis. So what did you just say? I said that here, notice this. This is the graph of cos x. Can you see this, everybody? It is there on the negative side of x-axis comfortably, continuously. It is there on the positive side of x-axis comfortably. But if you just notice its chunk, one chunk if you notice, don't you see or notice that, sir, here, at 0 it is 1, at pi by 2 it is minus 1, and so on. So there is simply a shift by 90 degree along with the x-axis on the left hand side. So sir, how do we utilize that information here? So if I first of all tell you one more thing regarding sine. Sine is a periodic function. Sir, what do you mean by periodic function? Periodic function here means that if you notice its graph, this portion, the same portion you just copy and keep pasting the same chunk. If you just keep copy and paste, this chunk will keep on getting repeated. So this chunk which has a length 2 pi, the same length 2 pi to 4 pi, 4 pi to 6 pi, and so on, will keep on getting repeated. So what does it mean? It means it is a periodic function. It is a periodic function with its period, which usually or conventionally defined as t, as 2 pi. Similarly, if I now take you towards cos x, yes, the same graph repeats, but with a slight change, that here it goes like this. So here you would clearly notice that this time At 0, it is 1. At pi by 2, it is 0. At pi, it is minus 1. Then again at 3 pi by 2, it is 0. Then at 2 pi, it is 1. Then at 5 pi by 2, it is 0. At 3 pi, it is minus 1. So I hope while I was mentioning these angles and their values, you must have cracked what am I talking about. First of all, I hope need not tell you that here again, x can take any real value and cos x still lies between minus 1 and 1. Everybody agrees with me on this? Absolutely. Cos x is also a periodic function. If you notice its nature from 0 to 2 pi, the same chunk keeps on getting repeated, which means this is again a periodic function with a period 2 pi. But sir, again, if you ask me few things, three major things. First thing, if somebody says that cos x is 0, what is your conclusion? I'll say cos x is 0. Cos x is 0 at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, minus pi by 2, minus 3 pi by 2, and so on. Which means whenever cos x is 0, x will be an odd multiple of pi by 2. I hope you do agree that if cos x is 0, I'll say x will be an odd. Odd is either 2n plus 1 or 2n minus 1. So there again, n is an integer. So whether 2n plus 1 pi by 2 you do or 2n minus 1 pi by 2 you do, it will be an odd number or odd multiple of pi by 2. Have you all been able to understand what I have said so far? Everybody. Excellent, Vijay. Good. Similarly, if I ask you, when do you find cos x to be 1 and when do you find cos x to be minus 1? Can you help me with that data as well? Can you help me with that data as well, everybody? So sir, cos x is 1. Is that what you're asking? Yes. So cos x will be 1 at 0, then at 2 pi, then I think at 4 pi, 6 pi, 8 pi. So sir, even multiples of pi if you take, their cos x will be 1. So here x will be even multiple of pi. So even means 2n. Yes or no? And what about minus 1 students? When do you see cos x to be minus 1? When are we noticing that cos x is minus 1? Sir, it is minus 1 at pi, then at 3 pi, then 5 pi, 7 pi, and so on. So at odd multiples of pi, it is minus 1. Sir, what about this function, even or odd? Is it even? Is it odd? What kind of function it is? Everybody. Good, Vijay. Keep it up. Really nice. So if you ask us this function, whether it is even or odd, I'll say this time the curve is symmetrical with respect to the y-axis, which means whatever is the graph on the left of y, the same is on the right of y. So y-axis, if behaves as a mirror for a curve, then such function is said to be an even function. So this time cos is an even function, which means here, even function means f of minus x will be equal to f of x, which means in case of cos of minus x will be equal to cos x. Absolutely, absolutely, absolutely. Did you all get this part? Everybody comfortably understood it? Any queries? Now let's talk about 10. Everybody, focus here. Let's talk about 10 now. So what is 10? Let's do it, everyone. So if I wish to define 10x, here, look at this. Look at this curve, everybody. Can you notice this? This is how the graph of 10x look like. Sir, what does it mean? I'll show it to you. This is how the graph of 10x look like. I hope you can notice it. This is how the graph of 10x look like. I hope you can clearly notice. I hope if I zoom it out, it looks like parallel lines. If I zoom it in, it looks like a straight line, y is equals to x. But sir, what exactly are we doing here? What do you really mean by this? Can you really demonstrate it more clearly? Yes. Let's talk about the graph of 10, everyone. So please pay attention. We are now going to talk about 10x. So let's say this is x-axis here. And this is y-axis over here. And parallel to it, there are some lines which I'm just drawing to make your understanding more better, but give me some time so that I can precisely help you out with whatever I'm trying to do here. So you just need to be a little patient and just look at this thing, which will make you understand everything. So here, let's say this was our y-axis, this was our x-axis. I'm locating some points like 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on. Similarly, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on. So when you notice the graph of 10x, so you would notice something really amazing that, sir, first of all, it is recursion. It's a tool online available. You just look for this tool. You can draw any graph. So here, if you notice the curvature from 0 to pi by 2, it goes like this. From minus pi by 2 to 0, it goes like this. And the same pattern, absolutely from internet only, the same pattern, the same chunk, repeats from pi to 3 pi by 2 like this, and from pi by 2 to pi like this. The same chunk repeats from minus pi to minus pi by 2 like this, and from minus 3 pi by 2 to minus pi like this. The same chunk, keeps on getting repeated. So, sir, what does it really mean? This thing over here means that here, minus pi by 2, pi by 2, 3 pi by 2, these are all those points where 10x becomes not defined. Where these lines, which are parallel to the y-axis at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, at these points, they become asymptotes. So what are asymptotes? Asymptotes are the tangents to the curve which connect it or touch it at infinity. So this will keep getting closer, but it will never touch pi by 2. Yes, Kavita, I'm doing it. I'm doing it for you only. I have heard you. Trust me, I'm doing it. So this chunk keeps on getting repeated, first of all. And what chunk is getting repeated? From minus pi by 2 to pi by 2. So this is a distance pi. So first of all, this is again a periodic function with a period pi. But if you look at 10x, 10x will always be not defined whenever cos x becomes 0, because 10x is sin x upon cos x. Denominator we can never afford to keep 0. So cos x can never be 0. Sir, when is cos x 0? I hope you do remember. At all the odd multiples of pi by 2, cos x is 0. So at all the odd multiples of pi by 2, 10x will be not defined. Did you get my point, or shall I repeat it to all the participants? Everybody understanding this fact? All the participants, yes or no? So what did I just say? That here, 10x, if you want to talk about, sir, it will be defined for all x which are real, but for odd multiples of pi by 2, it will not exist. It will not exist. Did you all get my point? But sir, what about its range? I'll say, sir, I can clearly see it is there from minus infinity to infinity. Its graph is there from minus infinity to infinity. It is there everywhere along with the y-axis. So if you ask me its range, which is y, so 10x can take any real value. All the participants got my point, or shall I repeat it? Everybody, yes or no? From here, I think we can talk about one more thing. Is it an odd function or even function, students? Is it an odd function or even function? Sir, look at this. It is symmetrical with respect to origin in the opposite quadrant. Whatever is the curvature in the first quadrant, the same curvature you are seeing in the third quadrant, which means it is clearly an odd function. Odd function means 10 of minus x will be minus of 10x. Yes or no, everybody, yes or no? Are you all comfortably understanding it, everybody? With this, sir, what do we conclude? Okay, one more question I have. Can you answer this question? If somebody claims that 10x is 0, if somebody claims that 10x is 0, what do you know about that? Sir, I'll say, whenever sin x is 0, whenever sin x is 0, tan x will be 0 because tan x is sin x upon cos x. And when do we see sin x to be 0? Sir, sin x is 0 at all the multiples of pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi. So tan x will be 0 whenever x is n pi category, where n is an integer. Simple, easy, direct, straightforward. Yes or no, all the participants. Did you all get this, whatever I've explained so far, without any confusion? Please respond. Any queries? Absolutely, Vijay. Excellent. With this, if I move further, I'll just take you through sec, cosec and cot very quickly now. So let us first of all draw the cot. Now I'll draw a very quick one. Cot's graph, if you draw, it goes like this. It goes like this. Then it again goes like this. And this is how it keeps on going like this. It keeps on going like this. So first of all, cot will stay between 0 to pi, then from pi to 2 pi, minus pi to 0, and so on. So at minus pi by 2, at pi by 2, at 3 pi by 2, at all the odd multiples of pi by 2, it will become 0. Because what is cot now? What is cot? If you notice, cot is actually cos upon sine. So wherever cos is 0, cot will be 0. Cos is 0 at odd multiples of pi by 2. So pi by 2, 3 pi by 2, 5 pi by 2, those are the points where cot is 0. And wherever sin x is 0, cot will be not defined because cot is cos upon sine. So whenever denominator is 0, cot becomes not defined. Sin x is 0 at 0, pi, 2 pi, 3 pi, multiples of pi. So 0, pi, 2 pi, 3 pi, minus 2 pi. There, cot x will be not defined. I hope we are not making it way too complicated. You are able to digest, understand and comprehend everything, whatever is explained so far, comfortably. Yes or no? Shall I move ahead from here, all the participants? But again, sir, if you talk about its domain and range, what do you think, sir? So I'll say domain means x can be anything, but sir, it cannot take any multiple of pi. Because at any multiple of pi, sine will become 0. And if sine becomes 0, cot will be not defined. But again, if I talk in terms of range, don't you think the graph exists from minus infinity to infinity everywhere? Which means what? Which means if I talk about the range, it is all the real numbers. What about odd or even, students? What do you think? Is it an odd function or an even function? Can you help me with that? What is cot? 1 upon 10. 10 was odd. Cot will be odd. Don't you think so? Logically. What did I just say? I said a very beautiful, straightforward, direct fact that with respect to origin, it is symmetrical in the opposite quadrants. Don't you see this? So cot is like 10, an odd function. So cot of minus x will be cot x. Sir, is cot x also a periodic function? Technically, all the trigonometric functions are periodic. Cot is also periodic with the period pi. I hope you do notice that this chunk is getting repeated. Pi distance is getting repeated every time. So cot is again a periodic function with period pi, the way 10 was. One more thing I'll ask you, that if somebody ever claims that cot x is 0, then what do we interpret by this? Sir, cot x is 0, right? Cot x is 0 wherever cos x is 0. Cos x is 0 at all the odd multiples of pi by 2. So cot x will be also 0 at odd multiples of pi by 2. Yes or no? I hope this is all very simple, easy, direct, straightforward and understandable. Shall I continue further with some more interesting ones? Shall I show you the graph of sec x, everybody? Are you interested in understanding the graph of sec x, everybody? Please pay attention. This is more interesting. I'll begin with cosec and then we'll go to sec, everybody. Pay attention. I'm going to explain the graph of cosec x. So here we have the graph of cosec x. Sir, what is this? Sir, what is this? What is this? Okay, so this looked like something, but sir, what exactly is this? I'll try and help you out with the graph of sine first. I hope I have given you a clear idea, but this still looks confusing. So let me help you out with some more versions or better idea. Can you help me with the graph of sine? Yes, sir, we can. How does the graph of sine look like? So, sir, if I just locate few things, if I could just locate few things. Few things means what? Sir, this is 0, let's say this is pi. This is, let's say, 2 pi. This, let's say, is minus pi. There will be minus 2 pi as well. So in between minus pi by 2, this is plus pi by 2. This is plus 3 pi by 2. Everybody comfortably getting it? Now, I hope you do agree that somewhere here it will be 1. And somewhere here it will be minus 1. So somewhere here this is 1 and this is minus 1. Sir, why are we really doing it? Now go back to the graph of sine. Go back to the graph of sine. Sine used to move like this. Sine used to move like this. This was the graph of sine. I hope you do remember, although I did not draw it properly. This is how sine used to move. I'm not able to draw it very properly, but I hope you do understand. This is how the sin x curvature look like. Yes or no? So you just invert these buckets. This bucket, if you were able to draw, invert it like this. This bucket, if you were able to draw, invert it like this. Sir, why are we really doing it? We are inverting them because sine was between minus 1 and 1. What is cosec? Cosec is reciprocal of sine. So if sine is confined between minus 1 and 1, don't you think cosec will be either less than minus 1 or greater than 1? Can you imagine this? What I'm saying here is, please pay attention everyone, something really important and crucial I'm trying to make you all understand. That here, let's say this is a line passing through pi. This is a line passing through 2 pi. This is a line parallel to the y-axis passing through minus pi. So I hope you do remember that sine x used to stay like this between 0 to pi. So cosec x will stay like this. Will stay like this. This curvature will stay like this, where it will never touch y-axis or this line parallel to y-axis at pi, 2 pi, 3 pi, 4 pi. Because if sin x becomes 0, cosec x will not be defined. Sir, when is sin x 0? Sin x is 0 at all the multiples of pi. 0, pi, 2 pi, 3 pi, 4 pi. There sin x is 0. So reciprocal of sine is cosec. So cosec will be not defined at multiples of pi. Got my point, or shall I re-explain this idea? Everybody. So between pi to 2 pi, sine has a curvature like this, but cosec will have a curvature like this. Between minus pi to 0, sine has a curvature like this, but cosec will have a curvature like this. I hope it makes some sense. Are you all able to process this? The graph of cosec I'm trying to explain over here. Yes or no? All the participants. Excellent, Vijay. Absolutely. So first of all, when we talk about y is equal to cosec x, I hope you do agree that, sir, x can be any real number except for those points where sine is 0. Where is sine 0? So sine is 0 at multiples of pi. So it can be anything except for n pi. Sir, what about the range? I think you know better than me this time that, sir, it is either absolutely above than 1 or absolutely below than minus 1. So don't you think that range this time will be minus infinity to minus 1 or 1 to infinity? Everybody agrees with me on this. Yes or no? Yes or no? All the participants. The way sine was an odd function, do you not realize cosec will also be an odd function? So here I'll claim that cosec is also an odd function. Similarly, one more fact you should remember here is this, that everybody, please pay attention, a direct result, that the way sine was, cosec is also an periodic function. It is also a periodic function. Sir, why? Because this chunk now will keep on getting repeated. So this is a periodic function with the same period 2 pi. I hope it makes complete sense. No confusion so far. The same graph will draw for sec with a minute change that it will again get shifted. Are you getting my point, everyone? Let's say if this is 0, this is a point pi by 2, minus pi by 2. Then this is a point 3 pi by 2. Then this is a point minus 3 pi by 2, like that. So this is, let's say, 0. This is pi by 2. This is pi. This is 3 pi by 2. This is minus pi by 2. This is minus pi. This is minus 3 pi by 2. First of all, I hope you do get this idea that cos was an even function. Sec will also be an even function, which means it will be symmetrical with respect to the y-axis. Yes or no? There. Again, just focus on one thing. There will be 1 on the y-axis somewhere. There will be minus 1 on the y-axis somewhere. So here, if this is 1 and this is minus 1, don't you think the way cosec was either above 1 or below minus 1, sec will also be either above 1 or below minus 1? Because sec is reciprocal of cos. Cos stays between minus 1 and 1. So sec will be either less than minus 1 or greater than 1. Yes or no? Everybody give me a quick response. So with this, what do we conclude here? We conclude that, sir, at 0 it is 1. So from 0 to pi by 2 or minus pi by 2 to 0, it will stay like that. At pi, it is minus 1. But between pi by 2 and 3 pi by 2, it will stay like that. At minus pi, it is minus 1. But between minus 3 pi by 2 and minus pi by 2, it will stay like that. So this is how you draw the graph of sec x. So now what are we doing? We are discussing the last graph, which is sec x, which is again having x, the domain. I think all the values on the real axis it can take except for some values. Which values? Sir, cos x, wherever cos x becomes 0, sec will be not defined. Cosec becomes 0, cos x becomes 0 at all the odd multiples of pi by 2. So sec will become not defined at all the odd multiples of pi by 2. So I'll say r minus any odd multiple of pi by 2. What about range? Vijay has already written it. Excellent. Sir, either totally below minus 1 or greater than 1. So it will be minus infinity to minus 1 or 1 to infinity. I hope it makes complete sense, whatever we have understood so far. Any queries? Any queries? Now with this, we'll move towards the next part, which is domain and range of trigonometric, which we have already covered. And then we'll move towards some identities. Let's take a 10 minutes break, a quick break, and then we'll come back. So we are just taking a 10 minutes break. I hope that's fine. And then we'll resume. Is that okay, everyone? What has just happened? Okay, so if you all can hear me, if you all can see me, come back, everyone, come back. I hope I'm clearly visible and audible, students, and you all are there, listening, watching, and understanding. Everyone, give me a quick response. Am I again clearly visible and audible? Everybody, can you all hear me? Can you all see me? Shall we resume this session? Everybody, I hope if you have hydrated yourself, walked around, stretched, or had something, now finally come back, sit back, and start re-watching it. Everyone, shall we get started? Are you all there? So with this, whatever I have taught to you, let me just cover it all with one table. Shall we create one very quick table now? I am saying that let's say we have something like this, a complete table I'll create for you for your reference so that you never forget this. Because this is something which you'll be using not only in 11th standard, but in 12th as well at a lot of places and a lot many times. What is exactly that? So here, I'll be talking about all the other functions, all the functions which we have talked about or gone through, and then I'll just make you understand all of these one by one. So give me a moment, I'll just create a table and make you all understand this. And we'll understand it. We'll not rote it or mug it up. We'll understand it. Let me see how many. 1, 2, 3, 4, 5, 6, 7. So with this, if I have function here, I will talk about its domain and then its range, right? That will be sufficient. So we don't need like this. We'll just get it removed. I'll just bring it a little here. I'll just bring it a little there. I hope it works fine. So I'll talk about the function here. We'll talk about its domain here. And we'll talk about this range here. This table you should keep in mind. Yes. Throughout your entire 11th, 12th journey, you should keep this table in your mind, everybody. What does this table say? We'll talk about sine. We'll talk about cos. we'll talk about tan. We'll of course talk about cosec. We'll talk about sec, and we'll talk about cot. So one extra row I created, no worries. So what we do here is, I hope you do remember, sine and cos are very beautiful function in life. Their domain is sorted out. Tan is like r, cot is also like r, but sir, tan cannot take certain values. Which values? Wherever cos is 0. When is cos 0? Odd multiples of pi by 2. So I'll say r minus 2n minus 1 or 2n plus 1, whatever you wish to say, pi by 2, where n is an integer. Similarly, cot is also very much sorted like sine and cos, but it cannot be defined whenever sine is 0. Sine is 0 at multiples of pi. So r minus, I hope you do remember, n pi. You can simply write it like this, n pi, where n is again an integer. Sir, what about sec and cosec? I think sec and cosec are also very well defined, but they also behave like little like tan and cot. Why? Because sir, cosec is reciprocal of sine. So wherever sin x is 0, sec will be not defined. When do you see sin x to be 0? Here. So I think cosec and cot are behaving same. So cosec is also r minus n pi. Sec is like tan, because whenever cos is 0, sec and tan are not defined. So sec will say I'll be like 10 in terms of domain, r minus 2n plus 1 pi by 2 or 2n minus 1 pi by 2. I hope domain is very well understood by everyone. Any confusion if you have, please ask regarding domain of trigonometric functions. Now what about range? I hope you do get it very clearly. That's a sine cos tan. If you talk about sine and cos, so sine and cos again stay on the same page. Minus 1 to 1. They stay like that. Second cosec, reciprocal. So if sine and cos are between minus 1 and 1, sec and cosec are either below minus 1 or above 1 on the y-axis. Remember that? So sir, in that case, second cosec will be either minus infinity to minus 1 or 1 to infinity. Same is done by cosec and sec both. Yes or no? Yes or no? Everybody, are you able to visualize this? What about tan and cot? They exist everywhere along with the y-axis, which means tan and cot can take any real value. Everybody got it? Any queries or confusions if you have, please ask. Now, sir, we know the table. We know the table. What table, students? We know the table that, sir, if you say that theta is, let's say, 0 degree, 30 degree, 45 degree, 60 degree, or 90 degree. Or in terms of radian, if you want to define, you can say 0 radian, 30 means pi by 6 radian, 45 means pi by 4 radian, 60 degree means pi by 3 radians, 90 degree means pi by 2 radians. For these angles, we have learned certain values. Yes or no? We have learned these standard values already in 10th standard. A very quick revision of these values we'll do one more time here in 11th standard for sine, cos, tan, cosec, sec, cot. Sine, cos and tan, I'll tell you. Reciprocals you can do and find cosec, sec and cot respectively. Everybody remember that. So how I personally teach is that I say 0, 1, 2, 3, 4. And then divide all of them by 4. Divide all of them by 4. Divide all of them by 4. And then take their square roots. Take their square roots. It always works. Trust me. 0 by 4 is 0. So square root of 0 is 0. So this value over here is 0. 1 by 4 is 1 by 4. Its square root will be 1 by 2. Don't tell me plus minus 1 by 2. 2 by 4 is 1 by 2. Square root of 1 by 2 is 1 by root 2. 3 by 4's square root will be root 3 by 2. Yes or no? So this will be root 3 by 2. 4 by 4 is 1. So square root of 1 is 1. So this will clearly be 1. Any confusions? Please ask if there are any doubts, queries or concerns. That's good, Vijay. We know sine and cos are complementary in terms of angles. So whatever is sine 0, the same will be cos 90 degree. Whatever is cos 90 degree, the same will be sine 0 degree. Whatever is sine 30 degree, the same will be cos 60 degree. Whatever is cos 60 degree, same will be sine 30 degree. Whatever is sine 45, the same will be cos 45 or vice versa. I hope that's easy. Good, Vijay. Now, what is tan? Sir, we have just discussed in the beginning only. Tan is sine upon cos. So 0 upon 1, 0. This by this 2 and 2 are cancelled. Tan 30 degrees 1 by root, sorry, 1 by, yes, root 3. 1 by root 2, 1 by root 2 cancelled, 1. 2 and 2 are cancelled, tan 60 degrees root 3. 1 by 0 is clearly not defined. Yes or no? Any confusions? Absolutely, absolutely, Vijay. Good. But sir, apart from that, don't they ask you a lot of other values as well? Don't they ask you a lot of values based on quadrants and all? Yes. Then sir, what do we do there? What do we do there? So let's work on the quadrant theory now. Let us work on that quadrant. I hope their reciprocals you can find out by yourself easily. If I ask you cosec, if I ask you sec, if I ask you cot, you can do that quite easily. Yes or no? All the participants. You're comfortable with their reciprocals, aren't you? But sir, okay, we get it, we get it. Now, what do you mean by quadrant theory? So quadrant theory, what does it say? Here you have y-axis and there you have x-axis like this, right? So what I'm saying here is a very simple fact that here, if you have y-axis and x-axis like this, here, if I take 0 degree or 0 radian, if I rotate it by 90 degree, it becomes plus pi by 2 here. If I rotate it by one more pi by 2 here, it becomes pi by 2 plus pi by 2, that's pi. If I rotate it by one more pi by 2 here in clockwise, pi plus pi by 2 is clearly 3 pi by 2. Everyone processing this idea. 3 pi by 2 plus pi by 2 is clearly 2 pi. Then 2 pi plus pi by 2 is clearly 5 pi by 2. Then 5 pi by 2 plus pi by 2 is clearly 3 pi. 3 pi plus pi by 2 is clearly 7 pi by 2 and so on. So I hope you can keep rotating it in anti-clockwise direction and it will keep giving you lot of angles. But sir, if I could generalize it, how do I generalize it? 0, 2 pi, 4 pi, 8 pi, 6 pi, so on. So it is like even multiples of pi. Pi, 3 pi, 5 pi, 7 pi, which means it is like odd multiples of pi. So pi by 2, 5 pi by 2, 9 pi by 2, it's like 4n plus 1 kind of a multiple of pi by 2. 3, 7, 11, 15. So that's clearly 4n minus 1, or you can say 4n plus 3, whatever you wish to call it, times pi by 2. So I hope first of all you have been able to identify that what kind of angles there lie. Absolutely. Train Traveler by Sanjay. 271. Good. Excellent. So there, if I continue further, I am saying that here in the first quadrant, when you observe their graphs, when you notice the graphs, I hope you do know that between 0 to 90 degree or this kind of zone, all the ratios are positive. Whenever you notice their graphs, based on that, the generalization can be given. So we say here all the ratios are positive. But in the second quadrant, we say sine and its reciprocal cosec are positive. In the third quadrant, we say tan and its reciprocal cot are positive. And in the fourth quadrant, we say which two? Cos and sec are positive. Yes or no? Everybody. Okay, sir, we get it. But how do we utilize this table? What do we do with this? Okay, let me try and help you with some data. Let's say if I were to ask you certain values. I'll begin with this page. Pay attention, everyone. Let's say if I ask you, what do you think sine pi plus theta could be? So, sir, this is where you see pi. Yes. Plus theta if I do, that will push me in which quadrant? Third quadrant. So first of all, pi, where do you find it? Did you find it on x-axis or y-axis? Sir, on the x-axis. So if you find on the x-axis, the ratio doesn't change, which means you can write it as sine theta. But what about the sign, positive or negative? So look at this. In the third quadrant, tan and cot are positive, so sine will be negative. Isn't it beautiful and interesting? Can you not get any angle by using this periodicity by such ease? For example, I am saying, let's say if I ever ask you tan 2 pi minus theta, what would that be? First of all, locate where is 2 pi. So 2 pi you find here. Minus if you do, that means you move clockwise. So 2 pi minus theta. So this will be 2 pi minus theta, which means now I am where? I am clearly in the fourth quadrant. So if I am in the fourth quadrant, what will I see? Sir, in the fourth quadrant, first of all, 2 pi is found on the x-axis. So if you are on the x-axis, moving from the x-axis, the ratio doesn't change. So it will be first of all 10 theta. But what about the sign, plus or minus? Sir, in the fourth quadrant, cos and sec are positive. So 10 will be negative. Are you comprehending it comfortably? Or are you still feeling confused? Students, give me a quick response. Everybody getting it? Yes or no? Let's say I ask you cos pi by 2 plus theta. Cos pi by 2 plus theta. Give me a second, everyone. Sorry. What did I say? Cos pi by 2 plus theta. Sir, where is pi by 2? This is pi by 2. Pi by 2 we found where? Pi by 2, sir, we found on the y-axis. So if this thing is found on the y-axis, the ratios change. Ratios change means sine gets converted into cos, cos gets converted into sine. 10 gets converted into cot, cot gets converted into 10. Sec gets converted into cosec and cosec gets converted into sec, which means if you're moving from y-axis, cos gets converted into first of all sine. But sir, what about the signature, positive or negative? Okay, pi by 2 plus theta. Pi by 2 plus theta will push you in which quadrant? Sir, it will push me in the second quadrant. What happens in the second quadrant? Sir, sine and cosec are positive. So cos is negative. Everybody got it? Vijay, if you notice the graphs of tan and cot, if you notice the graphs of tan and cot, if you notice the graph of tan and cot, if you notice the graph of tan and cot, let me show you cot. Tan is very easy. Let's see cot. If you notice the graphs of tan and cot, so whenever you see the third quadrant, sir, what do you mean by third quadrant? Third quadrant means pi to 3 pi by 2 or 3 pi to 7 pi by 2, like these values. For these values, we notice that the graph lies above the x-axis only. Getting my point, Vijay? Whenever you see either in the first quadrant, like 0 to pi by 2 or 2 pi to 5 pi by 2, like that, in that case, or in the third quadrant, pi to 3 pi by 2, 3 pi to 7 pi by 2, like that, in those cases, tan x or cot x, the graph stays above the x-axis. The graph stays above the x-axis means it is on the positive side of y-axis. It is on the positive side of y-axis means what? Tan and cot are positive. So that's a pattern which it shows. And based on that pattern, we have given the generalizations. And based on those generalizations, we are writing all this. Have you understood it now, both of you? If you are understanding it sincerely, everybody. Any queries if you have, please ask. I hope no confusion. Shall we do more? Let's say if I ask you 10 7 pi by 2 minus theta. What do you think it could be? Okay, sir. First of all, locate 7 pi by 2. Sir, 7 pi by 2 is found here. Minus theta if you do, so you are loaded in the third quadrant. So first of all, 7 pi by 2, it is on the y-axis. So if we move from y-axis, the ratios change. So 10 changes into cot. Now what about the sign, plus or minus? Sir, in which quadrant you are? Third. So in the third quadrant, 10 is positive. So it will be plus cot theta. Everybody comfortably processing it, or are you still feeling confused? Do let me know if there is any confusion or query. Let me ask a few more questions. You tell me the answer. If you get it, I'll assume that you have understood it. Let's say if I ask you sine 8 pi plus theta, what do you think answer could be? One more question I'll ask you. Let's say cot 9 pi by 2 plus theta. Let me know what do you think could be the answer in both of the cases. In this first case, what do you think? So it's very easy. 8 pi. So multiples of pi which are even are found on the positive x-axis. So sir, in that case, this is where you are. 8 pi will be found here. So from x-axis, if you move, ratios don't change. So it will remain sine theta. But sir, what about 8 pi positive x-axis plus theta means first quadrant? That means everything is positive. All the ratios are positive. So if all the ratios are positive, this will be positive. Simple, isn't it? Direct, straightforward. I hope there is no confusion. Let's do one more. I asked you 9 pi by 2. 9 pi by 2. So I hope you do realize this is where you'll find 9 pi by 2, which means along with the positive y-axis. So if I move from positive y-axis left or right, the ratios change. So cot first of all will get converted into 10. But sir, what about the sign? Plus or minus? Okay, this is 9 pi by 2 plus theta. So plus theta will push me in which quadrant? Second quadrant. Sir, second quadrant has sine and cosec positive. Cot will be negative. So it's not plus 10 theta, it's minus 10 theta. I hope it was easy again. Are you understanding the modus operandi? Did you all understand the process? Everybody got this idea, yes or no? I hope this makes complete sense. You're comfortable with this now. Any queries if you have, please ask. Did you all get this idea? Yes or no? All the participants. Do let me know if there is any confusion, query or concern. I'll definitely resolve it. Otherwise, we'll move ahead. Shall we, everyone? Now with this, there comes some identities. There comes some identities. There comes some really important identities. I'll talk about this part 18 degree and all, but I really wish to talk about some important, really crucial identities. What are those identities? Let's talk about them. So now I'll begin with standard identities. Trigonometric identities, you may call them. So we'll be discussing a lot of identities. One by one, we'll discuss them, all those. So I just want you all to stay patient, alert, and focused now. Because whatever identities we are going to cover will be all for your syllabus. And these identities you will keep using not only in 11th but also in 12th. In 11th, not only in Trigo but in other chapters as well. In 12th, and a lot of other chapters, not only in ITF but also in calculus, integration, differentiation, at a lot of places you will need them. So it is not merely an independent chapter which you just learn and forget. This is a chapter which you keep using throughout your entire 11th-12th standard mathematics journey. So sir, what are those identities? I'll begin with the very first one, very popular one, which you all must be having at your fingertips. When I ask you sine A plus B, what do you mean by that? So sine A plus B is sine A cos B plus cos A sine B, isn't it, students? I hope you do agree with me on this. So sir, what do you mean by sine A minus B then? So if I ask you sine A minus B, what do you think it will be? The same result but with the negative sign. So it will be sine A cos B minus cos A sine B. Remember that result, students? Yes or no? When will class end? It will take some time. So if you are a trained traveler, I hope you have a lot of patience. So good things take time. Good, Vijay. Keep it up, really nice. Now, my next question is, this is A, by the way. Don't get confused. This is A over here. What if I ask you one more very important result? That if I add both of them, so I'm adding this to this. So on the LHS, what will I have? So on the LHS, I'll have sine A plus B plus sine A minus B. So what will I have on the RHS? Imagine this is added with this. So this and this are cancelled. So you'll get double of this. So you'll get 2 sine A cos B. So one more identity added to your list. Imagine this, I'm giving you all these identities in this PDF for your class 11th and 12th. You can utilize this PDF. You can keep this PDF with you. Whenever you need to revise trigonometric identities, formulae, ratios and everything, you have this cheat sheet with you. So keep it with you. Whenever you wish to revise formulae of trigo, you have this PDF and you can do it anytime. But sir, how can we have this PDF? By enrolling into our free batch. Free batch. The link is given in the description or in the comments as well. Free batch means you just enroll for it and you get this PDF as well as the notes. The notes and the doubt support system. 24/7 doubt support system. Yes, we'll be handling your doubts anytime. From wherever you ask. So, sir, can there be one more identity? Yes, actually, if I subtract this from this, so on the LHS, what will I have? On the LHS, I'll have sine A plus B minus sine A minus B. But sir, if I subtract this from this, minus plus sine A cos B will get cancelled. Cos A sine B will get doubled. So it will be 2 cos A sine B. So I think there are 4 identities first of all. Great. Good to have you, Sanjay. Any queries? So far, any doubts? Please ask. What if I make one change here? So what change? What change? Let me talk about that change now. What if I make a slight change here? Sir, what change? I am saying, say A plus B if I replace by C and A minus B if I replace by D. What happens in that case? So sir, if A plus B is C, A minus B is D, if you add both of them, B and B are cancelled. 2A will be C plus D. So A will be C plus D by 2. And similarly, B will be C minus D by 2. Sir, what are you exactly trying to do? I am trying to give you 2 more identities. Sine is sine. A plus B is C. Sine is sine. A minus B is D. So it gives you 2 sine A. What is A? C plus D by 2. Cos B. What is B? C minus D by 2. Did you all get this or shall I repeat it? With this, don't you think, sir, there can be one more identity? What could that be? Sine A plus B, which is C. Sine A minus B, which is D. Yes or no? But this time with a minus sign. Absolutely. So sine C minus sine D. What would that be? Sir, that will be 2 cos A. What is A? C plus D by 2 into sine B. What is that? C minus D by 2. Isn't it simple, direct, straightforward? I hope no confusion so far on whatsoever we have done. Everybody comfortably processing it? Yes or no? With this, I want you all to do one more thing. Sir, what thing? I want you all to do one more thing where I want you all to focus on creating something really good. That good is this, that let's say if I substitute B also by A. If I substitute B also by A, so this will be sine A plus A. So this will be sine A cos B, which is A, plus cos A sine A. Sine A cos A, sine A cos A. Don't you think it will be 2 sine A cos A? Which part are you asking me to repeat? Can you be more specific, Sanjay? And sine A plus A, what would that be, sir? Sine A plus A will be sine 2A. So we have created one more identity. Based on the same idea, if I replace B by 2A, I'll create one more identity, which is sine 3A. So sine 3A will be 3 sine A minus 4 sine cube A. Everybody with me so far on whatsoever we have done. Now, if I extend this idea a little further, I'll see some more coming on the way. Sir, what are those? Let's get started with those. If I ever ask you what is cos A plus B, so I hope this is a very fundamental identity which you all know, is cos A cos B minus sin A sin B. Don't you know that, everybody? Similarly, one more fundamental identity which you all must have understood is cos A minus B. Sir, in that case, you put a plus in between. So that becomes cos A cos B plus sine A, sine B. Okay. Sanjay, if you focus on this one, you will understand the logic there. Trust me, have patience. I'll explain that same thing, but from cos perspective again. So have patience, you'll understand it, don't worry. Good, Vijay. Excellent. Brilliant. Really nice. So there I'm asking you to look at this one, which is again a very interesting one if you use your brain. How? Look at this. These two you already know. What if we add both of them? So if their LHS are added, sir, cos A plus B, cos A minus B, when added gives you cos A plus B plus cos A minus B. Yes or no? But sir, when their RHS are added, sin A, sin B cancelled. Cos A, cos B, cos A, cos B when added, it gives you 2 cos A, cos B. Yes or no? Yes, sir, that's what we get. With this, if I tell you one more identity coming into picture, sir, what if we subtract this from this? So, what will I have? तुम हो अभी तक? Thank you so much. शक्कर डाली है क्या? शक्कर नहीं डाली. मुझे पानी और दे दो यार. मेरी बॉटल रखी है वहीं. गर्म. थोड़ा कुनकुना. ठंडा नहीं. So, our office boy, one of our office boy is still here. So he has just handed over coffee to me. So they are still here late night. We believe that usually there are teachers working here, but he's here. So he just handed over the coffee to me. So thanks to him, he'll keep me awake, charged and active so that I can teach you more effectively and efficiently. So we are coming back. What did I just say? I'll surprise you a little here, but have patience and don't get confused. Subtracting this from this. So on the LHS, it will be cos A plus B minus cos A minus B. Everybody listening and understanding, participants? Yes or no? So what happens on the RHS? Imagine this. Minus, minus. Because this is getting subtracted. So cos A cos B minus cos A cos B. Cancelled. Minus sin A sin B minus sin A sin B. That will be minus 2A sin A sin B. That will be minus 2A sin A sin B. That will be minus 2 sin A sin B. Sir, what are you really talking about? Can you be more specific? I am saying that this version has its own a lot of variance. Sir, which version are you talking about? This version, the last one which I have just written. Let's say you have OCD. You don't like this minus over here. So this minus needs to be adjusted somewhere. So one way to adjust it, take that minus sign here. So other way could be, if that minus is brought here, this becomes minus, this becomes plus. So in that case, it will become cos A minus B minus cos A plus B is equal to 2 sin A sin B. Everybody got this? Coffee ad is getting, sir. Really, Vijay? So is this how is it working now? Analytics, if I'm mentioning coffee in a live, they will show you an ad on coffee. Really? Unbelievable. I mean, if that's true, it may be a coincidence or it may be programming. I'm really clueless about what you're mentioning and asking. Are you? So I'm not the right person to answer this question. Really sorry. By the way, keep it up. If you're sincerely and genuinely doing it, gymming, running, jogging, cycling, swimming, you're staying physically active, mentally boosted, and financially and economically also you're getting better. That's a good spirit. Keep it up. But I hope it's ethical, it's correct, it's authentic. Nothing wrong or inappropriate methods are involved there. I hope so. Yes, my friend, I'm answering to you only. You don't have to post it time and again. I got your message. I understood it. Okay, so with this, let's get back everyone. Listen to this part. Sir, we don't like it. We still don't like it. Can we still rearrange it? Yes, there is still a scope of rearranging it. One more way is there, but don't you think that, whatever you try to do, it wouldn't change much? Yes or no? So these two versions you'll remember, I hope, and you will. Good to have you, Sanjay from Tamil Nadu. Oh, sir, excellent. Don't apologize, man. It's simply a question which you're asking to a wrong person. I'm not the right person. Simple. Coming back to all of this, I think we can create some more regarding which I think Sanjay was asking a doubt. So, Sanjay, let me clarify your doubt with one statement. I am saying that this one and this one, can we convert it into some more? Sir, which more? Let me just do one thing. Just copy it. Yes. So what did I just do? I am saying that here, Sanjay, this is for you. What is Vijay saying, sir? How to get sine pi plus theta? That's simple, Vijay. I'll explain it. Let me just get it done. I'll explain that part as well. Sanjay, I was saying that let's say a plus b I take as c and a minus b if I take as d. What if you add both of them? B and B are cancelled. So 2a you receive as c plus d. So a you receive as c plus d by 2. Did you get it, Sanjay, my friend? Similarly, if I subtract means what? Minus, plus, minus. So a and a are cancelled. So there I get 2b as c minus d. So that leaves you with b as c minus d by 2. So these two major changes or substitutions I am making. Which, sir? I am saying that if a plus b gets replaced by c and if a minus b gets replaced by d, then what happens is a can be replaced by c plus d by 2 and b can be replaced by c minus d by 2. Did you get my point, everyone? With that, you see something really amazing. This thing, which is cos a plus b, can be written as cos c, yes or no? Plus cos a minus b can be written as cos d, which is 2 cos a, which is c plus d by 2, cos b, which is c minus d by 2. Everybody got it, or are you still confused? Let me know it. Everybody comfortably got it, all the participants. Similarly, don't you think that here cos a plus b, which is cos c, minus cos a minus b, which is cos d, will be minus 2 sine a, which is c plus d by 2, sine b, which is c minus d by 2. Everybody got this result, or are you still feeling confused? Especially Sanjay, you got confused. You asked me to re-explain it. So did you get it now? Are you still feeling confused? Everybody comfortable? Now, one more thing I want you all to do is, let's say, sir, we have OCD. We want to arrange it. We don't like this minus sign. We don't appreciate this minus sign over here. So how can I get rid of this minus sign? So again, there are two ways. Either you push this minus somewhere here, or you push this minus here. So in two possible ways you can arrange it. Let's say minus sign I have brought here. So it can be written as cos d minus cos c, which is 2 sine c plus d by 2 times sine c minus d by 2. So in that case, RHS looks sorted, but LHS is not like that convention, that tradition we are seeing. Sine a plus sine b, sine a minus sine b, cos a plus cos b, cos a minus cos b. So it is slightly changed. Okay, sir, we don't want to settle the LHS. We want to keep the LHS like that. Okay, so you don't want to touch it. Yes, I don't want to touch it. I want to keep it as cos c minus cos d. The tradition I don't want to break. Okay, so you'll have to adjust it somewhere here. I don't do much here, so I'll keep it as 2 sine c plus d by 2 here. But this minus can be pushed here because sine is an odd function. Sine c minus d by 2 with this minus outside can be pushed inside and written as d minus c by 2. Everybody understood all the three variants comfortably, or are you still confused? That's good, Vijay. Really nice. all the participants, have you all understood it comfortably, or is there still any confusion? Please ask. If there are any queries or concerns, please ask. If there is any doubt, any confusion if you have, please ask. I'll gladly respond. I will gladly respond. Any queries or confusion if you have, please ask. Everybody. Shall we move ahead from here? With this, the story doesn't end here, unfortunately. The story actually starts here, because here, in this variant, if I play with the data, let's say, if I simply substitute B by A, so what change happens here is, this becomes cos A plus A. There it becomes cos A minus sin A. So I hope you do agree that, sir, cos A plus A is clearly cos 2A. Cos A plus A is clearly cos 2A. Cos A can be written as cos square A. Sin A can be written as sin square A. So one more identity added to your beautiful life. Absolutely, Vijay. Cos 2A is cos square A minus sin square A. But sir, we have learned something in 10th standard. Sin square theta plus cos square theta is 1. Can we club that information here? Yes. With that, what you'll get is, absolutely, Vijay. What you'll get is, I hope you do realize that here, if this sign, this cos 2A stays like that, cos square A stays like that, but if sin square A is replaced by 1 minus cos square A, do you all notice that if minus is pushed inside, you will get minus 1 plus cos square A. Cos square A plus cos square A is 2 cos square A. So this will lead into 2 cos square A minus 1. One more identity added to your beautiful life. Sir, what if I don't want to convert it into cos? What if I want to keep it in sin? Yes, you have the total liberty. Cos square A, I can write as 1 minus sin square A. Sin square A is already there. So sin square A will make it 2 sin square A. So I'll get one more. What is that? That is 2 sin square A. Yes or no? Everybody understood all of these 3 versions, but they are not merely 3. There are more based on it. Okay. I'll come back to this one. Remember that one? Sir, which one? The one which I told you there. When I mentioned this thing, that sin 2A is 2 sin A cos A. Sin 2A is 2 sin A cos A. Yes or no? Sir, what if we multiply numerator and denominator both by cos A? So if I do that, if I multiply it by cos A, it becomes cos square A. If I divide it by cos A, it becomes this. I hope it is still balanced, isn't it? But sir, what are you really trying to do? I am saying that sine upon cos, what is that? So that is 10. And this cos square A, if I push in the denominator, can be written as sec square A. Depends on the question actually, Sanjay. It depends on the question. So you just cannot say something is more important, something is less important. Everything is equally important. They can ask you anything depending on the requirement of the question you are supposed to use. So sec square theta we know is 1 plus tan square theta. So unfortunately you get one more identity added to your life, is that sin 2A. Sin 2A is 2 tan A upon 1 plus tan square A. I hope I'm not confusing you all with all of this information, yes or no? Similarly, for cos 2A, what we know is, sir, it is either for cos 2A, what we know is it is cos square A minus sin square A. Remember that, everyone. What if I take cos square A common? Yes. If I take cos square A common, so this will become 1. This will become sin square A upon cos square A. Yes or no? Everybody understanding whatever I'm doing here? Sir, what are you exactly trying to do? I am saying 1 is 1, sine square a upon cos square a is tan square a, and this cos square a from the numerator can be pushed in the denominator as again sec square a. Yes, Vijay, absolutely. And as I have clearly told you, sec square theta is 1 plus tan square theta. So I'll not hesitate in substituting this sec square a as 1 plus tan square a. So one more beautiful identity added to your beautiful life. Cheers to the coffee. Any confusions? Please ask if there are any doubts, queries, or concerns. Excellent. Shall I move further? If you all are comfortable with whatsoever done so far, are you realizing I have really done nothing? I've played with the two basic identities, sine a plus b and cos a plus b. All whatsoever I have developed so far is generated based on just those two identities, if you remember that. I have really done nothing else. So if you remember sine a plus b, sine a cos b plus cos a sine b, cos a plus b, cos a cos b minus sine a sine b, you're done. You're done. I have really done nothing else. All whatsoever I've done so far is simply based on that. Do you all agree? Now, based on that only, let me develop few more. Sir, are you serious about that? Yes. What is sine a plus b, students? Sir, sine a plus b is, can I just write it like this? Sine a cos b plus cos a sine b. What is cos a plus b, students? Sir, cos a plus b, if you are asking us, cos a plus b is cos a cos b minus sine a sine b. Remember that, everyone, students. So what if I divide this by this? I mean this by this. So this by this. Simple, isn't it? So sine theta upon cos theta, what is that? Sir, that is tan theta. That is tan theta. That is tan theta. So here what if I do this? Numerator and denominator both I divide by cos a cos b. So numerator I'm dividing by cos a cos b. Numerator I'm dividing by cos a cos b. So same thing should happen in the denominator. Denominator should also be divided by cos a cos b. Denominator should also be divided by cos a cos b. Sir, why are we really doing it? Have patience, have patience. You will understand something really amazing coming out of it. Sir, cos b nullified, cos a nullified, cos a cos b both are nullified. So on the LHS, what were we having? We were having tan a plus b. What are we having here? Sine a upon cos a. What is that? That's tan a. Sine b upon cos b. That's tan b divided by 1 minus sine a upon cos a. That's tan a. Sine b upon cos b. That's tan b. So with those two, we have added one more, haven't we? Absolutely, Sarthak, Sanjay, Vijay. Good, excellent. Did you all get this, or shall I re-explain this? All the participants. So with this, don't you think they can create one more? Sir, what do you mean by one more? By one more, I want to say, let's say if I ask you, same thing if I do, but on sine a minus b and cos a minus b, don't you think same thing will happen? And I'll get tan a minus b. I'll get tan a minus b. So sir, what will happen in that tan a minus b? It will become tan a minus tan b upon 1 plus tan a tan b. One more added to your beautiful life. I hope I'm not confusing anyone. I repeat, whatever I have done so far is clearly and strictly based on two results, sine a plus b and cos a plus b. Nothing new I have done, really nothing new. I've just played with them. We divide them sometimes, we multiply them sometimes, we do the a lot of some combinations I have tried with those results, and I have kept on getting a lot of newer versions, simply newer versions. Comfortably processing all whatsoever I've said so far. Any doubts or queries, if you have, please ask. Can I just play a little more with this data? Sir, what do you really mean by that? Let's do it. What if in this result I substitute B also by A? Okay, sir. So if B is also substituted by A, on the LHS you will get 10A plus A. So here you'll get 10A plus 10A divided by 1 minus 10A, 10A. Everybody got this? Everybody. And what that could be? Sir, on the LHS, it will be 10A plus A, which is 10 2A. 10A plus 10A will be 2 10A, and 1 minus 10A 10A will be 1 minus 10 square A. Are you all comfortably understanding it without feeling or getting confused? All the participants, are you all there, listening, watching, and understanding it comfortably? Give me a quick response if there is any confusion. Did you all get this? Everybody? Or shall I re-explain this result? Can we move ahead, all the participants? Did you all get this beautiful, simple, straightforward, direct result? Any confusions if you have, please ask. Please ask. With this, one more interesting identity come into picture. I hope you do remember that we have indeed discussed sine 3a. I hope you do remember that was 3 sine a minus 4 sine cube a. We have discussed cos 3a. That was 4 cos cube a minus 3 cos a. Similarly, I'll give you one more, which is tan 3a. So this will be, pay attention everyone, 3 tan a minus tan cube a upon 1 minus 3 tan square a. So one more added to your list of formulae. Great, great, great. Excellent, excellent. Beautiful, really nice. So far, is there any confusion? So what if I add some more? Are you realizing it will work as a Bible for you of Trigo? This PDF, once you receive, you just keep it saved. All the identities with their proofs, detailed descriptions, everything is there in a very structured manner. So whenever you want to revise Trigo, because Trigo's identities you need to keep at your fingertips. You just cannot afford to forget them, because you keep using everywhere, whichever version comes, and I hope you do realize you can use them. You can memorize them, you can practice them, you can revise them with this PDF. How do you have this PDF? The link is given in the description. So free of cost, you can have it first of all. I want to take you back to one more version or variant, which is a very crucial one. Do you remember cos 2a? Sir, cos 2a is 2 cos square a minus 1. Okay. Not just that, but cos 2a has one more variant, which is 1 minus 2 sine square. Okay, sir, we get it. But what is the advantage of it? Let me tell you the advantage. If I take this 1 on the LHS, it will become 1 plus cos 2a. That's 2 cos square a. Sir, what is it really? I mean, once the session gets over, the PDF will be uploaded on our application, Sanjay. If I divide it by 2 on both these sides, you can clearly see that 1 plus cos 2a divided by 2 will be cos square a. So one more beautiful one got added to your list. Everyone understood it? Similarly here in this case, if I take cos 2a to the RHS, 2 sine square a to the LHS, I'll have 1 minus cos 2a is equal to 2 sine square a. If I simply divide it by 2 on both sides, it will be 1 minus cos 2a divided by 2 is equals to sine square a. So one more identity added to your list. Sir, is that it? Is that it? Is that it? This is not it. There is some more. Can I create one more? With your permission, Your Highness. So the next one, if I try to create, what would that be? Let me just introduce that one as well. If I could do this, 1 minus cos 2a, can you help me with this? And 1 plus cos 2a, can you help me with this? Sir, 1 minus cos 2a, which we have just learned, is 2 sine square a. 1 plus cos 2a, which we have just learned, is 2 cos square a. So I hope you do get it. 2 and 2 are cancelled. Sine square a upon cos square a is clearly 10 square a. So as per the need of the question, I could be using this one as well. Everybody comfortably getting it? Yes or no? Good to have you from class 8. I am sure you are able to understand it. Yes or no? Any confusion, any queries if you have, please ask. So sir, what is the really, application of it? What exactly do we do with this? I mean, what is the advantage of it? Okay, let me tell you the advantage. Let's say someday you're asked sine 75 degree. So sir, sine 75 degree, can we really find it? Yes, now you can. Sine 75. Can somebody tell me in the comments how do we find sine 75 and what could be the value of sine 75? Anyone? Sine 75 can I write as sine 45 plus 30 degree? And what is 45 plus 30? 75. But what is sine A plus B? So that is sine A cos B plus cos A sine B, isn't it? So can you help me with some values here over here, students? Sine A, sine 45 is 1 by root 2. Cos 30 is root 3 by 2. Plus cos 45 is 1 by root 2. Sine 30 is 1 by 2. So the denominator is clearly 2 root 2. Numerator is root 3 and there it is 1. So that's nothing but what? Sine 75 degree for you. Any confusions? Absolutely, absolutely, Mukesh. If you are so sincere, since 8th standard, I think by 11th standard, you will do wonders. If you are sincerely and genuinely saying this, I'm sure you would. I hope you remember sine and cos are complementary in nature in terms of angles. So if we have sine 75 degree, can you not say what will be cos 15 degree? 90 minus 75 is 15. So the same value will be held by cos 15 degree as well. Look at this result, understand it, and let me know if there is any confusion. If there is any query or doubt, please ask. I'll re-clarify. If there are any doubts or queries or concerns if you have, please let me know. I'll re-clarify, students. Everybody got this result? Everybody understood this result? Any doubts? Absolutely, absolutely, absolutely. Similarly, I'm giving you an assignment, a homework that can you tell me what could be sine 15 degree? Sir, we'll find cos 75 degree. Yes. Or other way to do it, the hint is you can do it like this. Sine 45 minus 30. Can't you do this? So sir, I think we have the answer. 45 minus 30. Minus. So I think you have already found the answer, haven't you? Sine 15 degree, don't you think orally you have done is clearly root 3 minus 1 upon 2 root 2. Everybody got this or shall I re-explain this? So based on that, I think if sine 15 we know, cos 75 also you know. Yes or no, everybody? I hope that's easy, understandable and doable. Look at this whole result. Any part of this is confusing, do let me know. I'll re-explain. Any part here is confusing, then do let me know. I will re-explain. People really struggle a lot and call it a derivation when they talk about 18 degree. I really don't get it. Why do they call it? Let's talk about 18 degree now. 18 degree. It is such a beautiful angle that it is again a very amazing angle actually. If I take theta as 18 degree, don't you think 5 times of it will be 90 degree and the magic will happen now? I repeat, if theta I take as 18 degree, 18 into 5 is 90. So 5 theta will be 90 degree. Can I write 5 theta as 2 theta plus 3 theta, which I know is clearly 90 degree? Can I say 2 theta is 90 minus 3 theta? Now you tell me, what do you want? You want cos 18 degree, sin 18 degree, whatever you want. So let's find sin 18 degree. Okay. So I take sine ratio on both sides. Let's take sine ratio on both sides. Let's take sine ratio on both sides. Everybody paying attention here? So if I take sine ratio on both sides, it is sine 2 theta is equals to sine 90 degree minus 3 theta. Sine 2 theta, can you help me with this? I hope you remember 2 sine theta cos theta. Sine 90 minus theta is cos theta, so this is cos 3 theta. Okay, so this is 2 sine theta cos theta. Cos 3 theta, what is that? Sir, cos 3 theta is 4 cos cube theta minus 3 cos theta. Now cos 18 degree is definitely not 0. So I can take cos 18 common and cancel from both sides. That's good, Vijay. That's good. That's good. That's very good. Very good. Excellent. So I hope you are clearly realizing this cos theta can be cancelled. So I'm left with 2 sine theta on the left hand side. This is 4 cos square theta on the RHS and minus 3. One thing here, if I wish to do, will you not be offended by that? Sir, what are you trying to do? I am saying that 2 sine theta I keep as it is. But this 4 cos square theta, can I write as 4 minus 4 sine square theta? Sir, what have you just done? I have simply replaced cos square theta by 1 minus sine square theta. That's good, Sarthak. Very good. Really amazing. So I hope you do agree. Cos square theta is 1 minus sine square theta. So this will be 4 minus 4 sine square theta. And that's minus 3. One thing I'm willing to do here is, let's say sine theta for a while, just to save my efforts, I'm replacing by t. Can I do so? So this is minus 4 sine square theta. If I push it in the left hand side, it will be 4t square. This is already 2 sine t, which is 2t. 4 minus 3 is 1. So if I bring it on the LHS, it is like this. Everybody getting this result without getting confused or feeling confused. Now what, sir? This is a quadratic. Quadratic is solved with this. T is equals to minus b plus minus under root over b square minus 4ac. 4 into 4, 16. Minus 16, but minus of minus 16 is plus 16 divided by 2a. So t will be minus 2. 16 plus 4 is 25 into 4. So 2 root 5. So minus 2 plus minus 2 root 5 divided by 8. So if I cancel a 2 in the numerator and denominator, what I finally get is, I get 2 values of t. What was t? Sine theta. What was theta? Theta was 18 degree. So I get 2 values of sine 18 degree. One value will be minus 1 plus root 5 by 4. And other value will be minus 1 minus root 5 by 4. If you take minus common from here, don't you think it will be minus of 1 plus root 5 by 4. Now let me take you to the graph of sine theta. Even if a rough graph I could show you, this is how the graph of sine theta looks like. So if this is 90 degree, this is 0 degree. At 90 we know it is 1. So somewhere here you will find 18 degree. So 18 degree will be something between 0 and 1. So it is definitely positive. I can definitely say that whatever sine 18 degree is, this is definitely between 0 and 1. This has to be between 0 and 1. So root 5 is positive, 1 is positive, 4 is positive, positive 1 positive is positive, negative of positive is negative. So this value is negative. So sine 18 degree cannot be negative. Absolutely, Vijay. Absolutely. 18 degree, first quadrant, positive. So this is negative, discarded. So I think we have gotten the value of sine 18 degree, which is root 5 minus 1 by 4. Everybody got this? Any confusions if you have, please ask. That's excellent, students. I'm really proud that you all are participating so actively and getting the answers. By the way, when I say what is sine 18 degree, don't you think some of you have already responded, I can track cos 72 degree as well? Can't I? Absolutely, Sarthak. Very good observation. Same as sine 18 degree. Yes or no? Little stars, I am here helping and assisting you. Yes or no? With this, what if I ask you to find, sine 36 degree. This one I'm giving you as a homework, but I'm giving you the hint as well. That's your homework question, and I'm giving you a hint as well. What is the hint, sir? Hint, I hope you do remember. Let's say instead of sine 36, let me give you the homework as cos 36. So I hope you do remember cos 36 can be written as cos 2 into 18 degree. Cos 2 theta. What is cos 2 theta? Sir, cos 2 theta is 2 cos square theta minus 1, or 1 minus 2 sine square theta. What is theta here? Theta is 18 degree. So I have given you the hint. Will you try it by yourself now? Sir, how can we really try by ourselves? By yourself, because sine 18 degree, you know, is already root 5 minus 1 by 4. You just need to square it, multiply it by 2, subtract it from 1. You will have cos 36 degree. I am really good, Poon Guru. Thank you so much, Poon Guru. Coming back to here, to our discussion. If I now know, let's say, by figuring it out, by solving it, cos 36 degree. Good to have you from Arjuna, and this is for you, everyone. All the Arjuna batch students of ours. This I am doing in a very detailed manner, all the theory. So if you want to revise it with this one shot, watch it here. I'm doing it totally in a very crystal clear manner. Absolutely, absolutely. Some of you have already started responding. Beautiful. I am saying complementary of 36 is 54. So if we know cos 36, the same value I'll be receiving for sine 54 degree as well. So calculation part I'm skipping and giving you as homework. Is there any confusion, students? Did you all get this part? Any queries or confusions? If you have, please ask. If you have any doubts, queries or concerns, please ask. We'll come to this part now, where we'll discuss a lot of general solutions. I'm just giving you this part. What if I'm given general solutions for a lot of things? So 1, 2, 3, 4, 5, 6, 7, 8. So I'll begin with this one, where I'll say, what if sine theta is sine alpha? Then we say theta is n pi plus minus 1 to the power n alpha. The derivation is really simple. You take alpha to the other side, you get sine theta minus sine alpha as 0. Now you help me, what is sine c minus sine d? Little stars, my friend, I don't get it. Second year classes. I am Deependra, taking classes for IIT JEE Mathematics of 11th and 12th standard on PW JEE English channel, YouTube, as well as the paid batches. ITF will also come very soon, Harshit. Don't worry, we'll bring everything. Physical quantities, Mukesh. I am teaching IIT JEE Mathematics. So I'm really not aware of what is physical quantities, first of all. Not very much aware with the syllabus as well. So whatever you ask me from 11th, 12th mathematics, I will be able to help you. So with this sine c minus sine d you'll get an equation, you solve it, and ultimately you'll be able to conclude it. So I'm just giving you a hint, not solving it completely. Is that okay? If you want me to do it, I'll do it once for this, but not for all the results. We will do it, Harshit, don't worry. We have already conducted some class for 12 boards already on this channel only, PW English Medium. And very soon we'll bring more, don't worry. For 11th and 12th both, simultaneously we are bringing classes. Don't worry, Harshit. So I hope you do remember, we have discussed sine c minus sine d. If you have forgotten, I'll just show it to you so that you don't forget it. Sine c minus sine d, where did I do it? Here I did it. Sine c minus sine d, do you remember? 2 cos c plus d by 2, sine c minus d by 2. That's exactly what I'm wanting you to use here. So if I use that result here, sine c minus sine d, that will be 2 cos c plus d by 2 into sine c minus d by 2. Now this product is 0. People say that this product is 0. So sir, if this product is 0, either this will be 0 or this will be 0. So when cos theta plus alpha by 2 is 0, or what I'll say is sine theta minus alpha by 2 is 0. Now can you help me with this 0? Cos is 0. Cos is 0. Cos is 0 at all the odd multiples of pi by 2. Remember that? So there I'll say that this theta plus alpha by 2 will be 2n minus 1 pi by 2. And in this case, sine of something is 0. So that is n pi. Any multiple of pi gives you sine 0. So this theta minus alpha by 2 will be n pi. Everybody processing this, comfortably getting it, all the participants. Now what to do now, sir? What to do now? What to do? Okay, so here, if I cancel this 2 by this 2, I think we get something in terms of theta. We want theta actually. So theta from here will be 2n minus 1 pi. 2n minus 1 pi minus alpha. But here if I look at this theta will be 2n pi plus alpha. So I have come or reached to a conclusion, sir. Good, Vijay. I am reaching to a conclusion that, sir, theta will be odd multiple of pi minus alpha or even multiple of pi plus alpha. That thing, can I write in a clubbed manner? Yes. Theta will be any multiple of pi plus or minus alpha. Plus or minus alpha. So depending on n, if n is odd, alpha should be subtracted. So can I say, I can write it like this. Don't you notice this? We'll do it. Don't worry. Don't worry, Sanjay. The doubt which you asked, which you have just deleted, that fortunately I have kept as a question in this. So I'll definitely do certain questions as well. This is the last part where I'm just covering the theory and then we'll move towards questions. I'll get done few questions. Few I'll give you as homework. Okay. So there we have, I am saying, sir, whenever any odd multiple of pi is taken, you subtract alpha. Whenever any even multiple of pi is taken, you add alpha. So any even multiple of pi when you take, alpha should be added. I hope you can imagine this, because n is even, it will be plus. Any odd multiple of pi is taken. Sure, Yatharth. Any odd multiple of pi if taken, I hope minus 1 to the power n will be odd, so alpha will get subtracted. Yes or no? Yes or no, everybody? So I hope you do realize that this thing clubs both of them, and that's exactly what I've written over here. With this, there comes one more. Sir, which one? I hope I now need not give you the formulae, the derivations. If I'm told cos theta is equals to cos alpha, then I hope you understand theta will be 2n pi plus minus alpha. Please remember this result. Next one, if I'm told tan theta to be tan alpha, then theta is given by n pi plus alpha. I hope no confusion. If I am told that sine theta is equals to sine alpha and cos theta is equals to cos alpha, both are true simultaneously. In that case, you will say that theta is 2n pi plus alpha. These are the proofs, results, direct conclusions. So I'm not giving you the derivations for all. I have given you the derivation for the first one. The same derivations can be done for all. I hope you will definitely remember them. Then there is one more. If I am told sine square theta is equals to sine square alpha, or if I'm told cos square theta is equals to cos square alpha, or if I'm told tan square theta is equals to tan square alpha. For all of them, there exists only one solution, same solution. Theta is n pi plus minus alpha. Theta is n pi plus minus alpha. Theta is n pi plus minus alpha. Sir, what are you really talking about? Is it not confusing? Let me clarify this. For example, let's say I am told sine theta is equals to 1 by 2. So I'll say sine theta is equal to sine 30 degree. 30 degree I can write as pi by 6. So if sine theta is sine alpha, we say theta is n pi plus minus 1 to the power n alpha. That's what I'm trying to explain. Did you get it now? Or are you still feeling confused? Do let me know. Let me explain it with one more example. Let's say if somebody says cos theta is equals to 1 by root 2. So we say cos theta is cos 45 degree. 45 degrees pi by 4. So cos theta is cos alpha. Then we say theta is 2n pi plus minus alpha. So 2n pi plus minus pi by 4. That's what I meant. Harshit, my friend, this is the third time I'm telling you, we are simultaneously running classes for 11th and 12th. Just check out our channel. Trust me. Similarly, if I let's say give you this example where I'm told, let's say tan theta is, let's say, root 3. So I'll say tan theta is equals to 10 root 3 is 60 degree. 60 degrees pi by 3. So if tan theta is tan alpha, we say theta is n pi plus alpha. Everybody got this result, or is there any confusion so far? Are you having any doubts? Did you get this general result idea? Let me take some more examples so that you get it more comfortably. Let me take two more examples. Let's say this one. Let's say if I am told something like this, sine square theta is equals to, let's say, 1 by 2. So I'll say sine square theta is equals to 1 by root 2 whole square. So I'll say sine square theta is equals to, what is 1 by root 2? 45 degree. So sine pi by 4 whole square. So we have just learned that sine square theta is sine square alpha. Then what do we say? We say theta is n pi plus minus alpha. Any confusion so far? Saad, my friend, if you didn't study trigonometry, once this session gets completed, watch it from the beginning. You will understand it totally. Mark my words. Somebody showering a lot of love. Who's that, by the way? May I know the name? Absolutely, Vijay. Keep it up. Really nice. You're one of those candidates or participants who stays focused and active. Really good, really good. Keep it up. With this, we will now move towards a lot of questions. But before we move towards a lot of questions, let us take a 10 minutes break again and then we'll resume after a break. Is that okay? Okay, so if you all can hear my voice, come back everyone. If you all can hear me, if you all can see me, we are resuming. The break is clearly over, and the part where we were discussing a lot of theory is over, and we'll be doing some questions now. So whatsoever we have done so far, I hope is very well understood by everyone, and we can now move towards some questions. So here comes your first question, everyone. Anyone from Arjuna English batch? I am. So this says A is given by this for all values of theta, then prove that. Okay, we'll do it, everyone. How do we do it? Let's talk about it. So there, if I just simplify this, sir, cos square theta is cos square theta. Can I write cos square theta as 1 minus sine square theta? And sine to the power 4 theta stays like that. So A I'm writing as sine theta to the power 4. Cos square theta I'm writing as 1 minus sine square theta. So can I write it as minus sine square theta plus 1 for a while like this? Everyone okay with this? Now what I do next is, for a while, just to save my efforts, let's say sine square theta I take as t if you are comfortable. So A now becomes t square minus t plus 1. Everyone comfortable? So when I take sine square theta as t, we know sine theta clearly lies between minus 1 and 1. We have done it. So can I say sine square theta will lie between 0 to 1? Do you all agree with me on this? Everybody, can I say so? What is sine square theta, sir? Sine square theta in our case is t technically. So I am concluding that t will take all the values from 0 to 1. Don't forget this result, everyone. Now, the next thing which we do here is, pay attention everyone, t square minus t plus 1. If I could convert it into a perfect square, what result will I get? Let me try and convert it into a perfect square. So, t square I keep as it is. This minus t, if I write as minus 2 into t into 1 by 2, I hope you are not having any problems if I do so. Sir, what have you really done? This 2 and this 2 are getting cancelled. I'm still having minus t. So this is minus t. But I'm just trying to convert it into a perfect square. Sir, this is 1. I'll talk about that one later. A square minus 2ab. So I need b square. What is b square? Sir, this is b. So b square will be 1 by 2 whole square. Sir, is it something you're doing in your dreams so that you can do add, subtract, multiply, anything as per your choice? No, I'm not doing anything as per my choice. I'm keeping everything balanced, where this 2 and this 2 will get cancelled. It is still minus t. But sir, this was 1 over here. You have added 1 by 4 to it. So if I have added 1 by 4 to it, as a teacher of maths, I know that I can subtract 1 by 4 from here so that it can remain balanced. And there was this one. So I really have not made any much big or huge change here. Yes or no? Do you all believe that? I hope you all can see it very clearly that here, this thing is clearly something really important, which will do a lot of good to us. Sir, first of all, don't you think there is a problem? No problem. Why? 2 and 2 are cancelled. It is t. This is t. 1 by 4 cancelled. This is 1. This is 1. So equation is totally and perfectly balanced. Nothing has changed. Trust me. Then, sir, why have you really done it? I have done it because now I am able to convert it into a perfect square, which is a square plus b square minus 2ab, which is a minus b whole square. 1 minus 1 by 4 is clearly 3 by 4. Correct me if I'm wrong. Everybody got this result? Any confusions if you have, please ask all the participants. Did you all get this? Did you all get this? Did you all understand this? Everybody, do respond. I hope there is no confusion. Okay, sir, then what do we do next? I think this is clearly A. Now look at this. We know t is from 0 to 1. Yes. What if I subtract 1 by 2? So if I subtract 1 by 2 minus 1 by 2 to t minus 1 by 2 to 1 minus 1 by 2 is 1 by 2. Yes or no? Do you all agree with me on this? Yes or no? What if I square all the three sides? Imagine this in your brain. You have a number which is from minus 1 by 2 to 1 by 2. So if you square all of these numbers, don't you think they will be 0 to 1 by 4? Their squares will be. So I hope you do realize that their squares will be t minus 1 by 2 when squared will be from 0 to 1 by 4. But sir, this is what we don't need. We actually need this plus 3 by 4. So I'll add 3 by 4 on all the three sides. So 0 plus 3 by 4 is 3 by 4. This is t minus 1 by 2 whole square plus 3 by 4. And here 1 by 4 plus 3 by 4 is 4 by 4, which is 1. Sir, what have you really achieved by doing this? I think I have achieved everything which you were supposed to do in this question if you are looking at this part logically. Sir, what do you really mean by that? I wish to say that what was this? Sir, in the middle of it, it is actually A. It is actually A. So we, I think, have cracked what is A. Sir, we have cracked that A will take the values from 3 by 4 to 1. And I think that's exactly what we were supposed to prove. Did you all understand this, or shall I re-explain this? All the participants, everybody, yes or no? Shall we do the next question in that case? Shall we try the next question, everybody? Yes or no? Give me a quick response if you all have understood this particular one. The next one, again, a very interesting, simple, direct, straightforward one. Before I try it, I'd request everyone to give it a try and then we'll discuss its solution together. Everyone, quickly, be quick and give it the answer. First of all, before you start solving it, I'll ask you to club 109 and 1081 and 1027 and 1063 together. So why? Have patience. 109 is 109 degree, I'll say. 1081, can I say, can be written as 1090 degree minus 9 degree. Similarly, if I take minus common from here, 1027 is 1027 degree. But here, 1063, can I write as 1090 degree minus 27 degree? If you all are comfortable with whatsoever I've done so far, do respond if there are any queries or concerns. Let me know if there is any doubt. Absolutely, absolutely great. Keep doing these questions along with me and keep solving and keep answering. Now look at this. 1090 degrees, 1090 degree. So nothing much can be done here. What is 1090 minus theta? That's cot theta. So this will be cot 9 degree. Minus, look at this part. 1027 is 1027 degree. But what is 1090 minus theta? That's cot theta. So this is cot 27 degree. I think the same operation we are doing, but with different theta over here. Okay. So before I do it, let me just do one thing here. Let me just do one thing, then I'll come back to this part where I am just wanting you to do one operation on tan theta plus cot theta. Can you help me? What can be the simplification of tan theta plus cot theta? Let's do it. So tan theta plus cot theta. Tan theta is what? Sin theta upon cos theta. What is cot theta? Cos theta upon sin theta. If I do the LCM thing, what will LCM say? Sin square theta plus cos square theta, that's 1 upon sin theta cos theta. Correct me if I'm wrong. What I can do is I can divide and multiply it by 2. So when I do that, I hope you do realize in the numerator it will be 2, in the denominator 2 sin theta cos theta is sin 2 theta. Yes or no, everybody? Yes or no, everybody? Yes or no? So that's exactly what I'm trying to say here, that if you have this tan theta plus cot theta, you can write it as 2 upon sin 2 theta. So this is sin 2 theta, double of 9 degree will be 18 degree, minus, this is again tan theta plus cot theta, so that is 2 upon sin 2 theta, 27's double is 54 degree. Correct me if I'm wrong. Everybody remember, we have just discussed both of these values, sin 54 degree and sin 18 degree. Sir, sin 54 degree we have not discussed. Can you tell us what is sin 54 degree? Okay, I think you already know it if you just focus on this data. Sir, what do you really mean by focusing on the data? Let me just help you with the simplification part over here. Here I am saying a very simple fact that this 2 and this 2 can be taken outside. So if this 2 and this 2 can be taken outside, here I'm left with 1 upon sin 18 degree. Remember that sin 18 degree we have worked out as root 5 minus 1 by 4. Everybody remember this? This is sin 54 degree, which I hope you remember is nothing but cos 36 degree. And a lot of you have already responded in the chat, what is cos 36 degree? I hope you do remember. Cos 36 degree is clearly root 5 plus 1 by 4. Do let me know if there is any confusion. So it's merely a matter of simplification now. Yes or no? Sir, yes. So simplification when I do, 4 and 4 also comes out. So it comes out as 8. Then I hope when 4 goes out, it is leaving you a 1 here. And this 4 simply gets multiplied here. Then, if I do again the LCM thing, it will be root 5 plus 1 minus root 5 minus 1. Yes or no? Correct me if I'm wrong. In the denominator, a plus b, a minus b. Root 5 plus 1 into root 5 minus 1, 5 minus 1. That is clearly 4. Correct me if I'm wrong. Everybody got this. Root 5 cancelled. 1 plus 1, 2, 2. So it is 8 into 2 by 4. So I think answer is 4. Any confusions? That's good, Vijay. That's brilliant. I'm sure everybody must have understood it by now. Any confusion if you have, please ask. I'll re-explain it if there are any queries or concerns. Do let me know if you did not understand any part of this question, everybody. Next question comes right there in front of you on the screen. Give it a try. How do we do this? Here. Solve this equation. So when you are asked to solve this equation, which is sine theta, sine 3 theta, and sine 5 theta sum. In IDJ, we tell a trick, but my hands are bounded. I'll simply keep it to the board's level. So in boards, I'll say sine C plus sine D. Can we apply that? I hope you do remember. If I club sine theta with sine 5 theta, and I'll keep for a while sine 3 theta aside. So if this and this are clubbed, do you remember sine C plus sine D? So that is 2 sine C plus D by 2. So theta plus 5 theta divided by 2 into cos C minus D by 2. So theta minus 5 theta divided by 2 plus sine 3 theta is equal to 0. Any confusions? If there are, please ask. Now, the next thing which I'll do is 5 theta plus theta, that is 6 theta. 6 theta by 2 is 3 theta. So this is sine 3 theta dot cos theta minus 5 theta minus 4 theta minus 4 by 2 is minus 2 theta. Cos is an even function, so cos minus 2 theta or cos 2 theta, both are same. And that I'll tell you in the batch. I am supposed to teach you that formula in the next class, Arpita, don't worry. And this is equal to 0. Everybody got this, or shall I re-explain this part, students? Yes or no? Everybody. Now, I hope you do realize that here, sine 3 theta, we can take common. So, I am taking sine 3 theta common. Then what am I now left with? I am left with 2 cos 2 theta, 2 cos 2 theta plus 1 is equal to 0. Any confusion? So, product of two things is 0, which means either sine 3 theta is 0 or 2 cos 2 theta plus 1 is 0, which means cos 2 theta is minus 1 by 2. Everybody got this result? Everybody understood this result? Yes or no? Now, sir, how do we solve this? How do we solve this? Give me a moment, everyone. I hope first part looks very simple, where somebody says, sir, sine theta is 0. Theta, I think, is clearly n pi. That's very easy. But, sir, when cos is minus 1 by 2, what do we really do? That is something we need to take care of. So, when cos is minus 1 by 2, we'll do both. Sine 3 theta is 0. So, whenever sine of anything is 0, we know that angle is a multiple of pi. Remember that? So, 3 theta will be a multiple of pi. So, from here, theta will be n pi by 3. That's my first conclusion. But along with this, there is OR going on. What happened? There is an OR going on. OR means this thing. Cos 2 theta is minus 1 by 2. So, cos 2 theta is minus 1 by 2. So, what is 1 by 2? What is 1 by 2? Sir, 1 by 2 is 60 degree. Remember that? Which is pi by 3. Very good, Vijay. That's good. That's good. So, I hope you remember cos in angle when we wish to shift 1 by 2 is clearly 60 degree, which is pi by 3. But sir, we are not looking for pi by 3. We need minus cos pi by 3. Can we write it? Yes. I hope you do remember cos pi minus theta. That is minus cos theta. So I'm doing opposite here. Minus cos theta I'm writing as cos pi minus theta. So can I write it as cos pi minus pi by 3? Cos pi minus pi by 3 will be minus cos pi by 3. So cos 2 theta I have received as cos 3 pi minus pi, that is 2 pi by 3. So I hope you do remember, we did discuss the general solution for cos as well, that if cos theta is equals to cos alpha, then theta is given by 2n pi plus minus alpha. Remember that? So 2 theta will be 2n pi plus minus alpha. Alpha is 2 pi by 3 in this case. 2, 2, 2 are cancelled. So theta will be n pi plus minus pi by 3. So there are two answers, either this or this. Any confusions? Please ask if there are. Very good, Vijay. Excellent. Keep it up. Really nice. Very good. With this, let us solve a few more questions so that you get more clarity. Let us solve again a very good one. Do we have some more questions? Yes, we do have. Let us solve this question over here. Again, a very good question, a very insightful one, and it will give you a lot of clarity here. Sir, what is this question? We are told alpha and beta are the solutions of this equation. A tan theta, B sec theta is equals to C. Then they are asking us to prove this result. How can we simplify this? That's my question. Can you just look at this quadratic? Can you just look at this quadratic? I'm asking you to simplify this quadratic. Sir, where do you see the quadratic? Come on, there is no quadratic at all. I am saying there is a quadratic. If you just look closely. Sir, there is a linear. There is a linear. I am saying quadratic because you see two roots. So can we not convert this linear into quadratic? But sir, how? How do we do that? I am saying a tan theta plus b sec theta, if you simply square it. Sir, if we simply square it, what do we mean by that? I am saying that here, let us take this c to the one side and this b sec theta to the other side. So what happens when you do that? Here, let me just do it. Let me simplify it. So here we have a tan theta. C if brought on the LHS looks like this. B sec theta when brought on the RHS looks like this. Everyone comfortable with this? If I now square it on both sides, so squaring gives you what? Squaring gives you, I hope I can do it here only. So square of this and square of this. So a tan theta minus c whole square will be a square tan square theta plus c square minus 2ac tan theta. Correct me if I'm wrong. On the RHS, it will be b square sec square theta. But what is sec square theta, students? In yes, Vijay, that's a good observation. I am skipping it as a part of my habit, but you should. In boards, definitely. You get marks for steps. If you avoid that, you will lose your marks. So sec square theta is 1 plus tan square theta. Yes or no? So I'll write it as 1 plus tan square theta. Any confusions? So if I rearrange this whole equation, if I rearrange this whole equation, so b tan square theta, b square tan square theta, a square tan square theta. So I'll write it as a square minus b square whole times tan square theta. Correct me if I'm wrong. Then there is a term in 2ac. So this is 2ac tan theta. And then c square minus b square, that's your constant term. Correct me if I'm wrong. Did you all get this result? Everybody comfortably understood it? Any queries or doubts if you have, please ask. I'll re-explain. Any part which you are not able to process, do let me know. Then what do we do next, sir? I'll say we were told alpha and beta are the solutions. So this is a quadratic in tan theta. So solutions will be tan alpha and tan beta, because theta can be either alpha or beta. So for this quadratic, solutions will be tan alpha and tan beta. Did you all get this? So can you help me with some of the roots? Sir, if tan alpha and tan beta are the roots, sum of the roots is minus b upon a, which will be 2ac upon a square minus b square. Getting it, everyone? What will be the product of the roots? Sir, product of the roots is tan alpha into tan beta. What would that be? C upon a, which is going to be c square minus b square upon a square minus b square. Everyone comfortably understanding it without getting confused? Do let me know if there is any query or confusion. Okay, sir, we get it, but now what? I think you have forgotten something really important, which we have learned as tan alpha plus beta. Kindly help me with tan alpha plus beta, students. What is tan alpha plus beta? Do write me in the comments. So tan alpha plus beta is tan alpha plus tan beta upon 1 minus tan alpha tan beta. So if I just substitute these values, what is tan alpha plus tan beta? This, which is 2ac whole divided by a square minus b square. Correct me if I'm wrong. This divided by 1. 1 is 1. Minus tan alpha tan beta. What is tan alpha tan beta? That is c square minus b square divided by a square minus b square. So it's simply now a matter of rearranging this data. Once I rearrange the data, my question will be totally solved. totally, absolutely solved. Yes or no? So if I now simplify this, what do I get? Let's talk about that. Numerator looks sorted, which is clearly 2ac upon 2ac upon a square minus b square. Yes or no? Denominator also looks sorted, where it is a square minus b square minus c square plus b square. Whole thing again gets divided by a square minus b square. So I hope you do realize that, sir, a square, b square, a square, b square are cancelled. So what am I now left with? I think I'm left with the final conclusion, which is 2ac in the numerator divided by b square cancelled. So it is a square minus bc square, which is what? Which is RHS. So I think we started with LHS. It is RHS, hence proved. Any confusions? Any queries? Please ask. If there are any doubts, if there are any concerns, do let me know. Shall we do some more questions, everybody? Great, brilliant. Now give this question a try, everybody. Try to solve this question. We'll solve it together. But before that, just look at the data. Root 3 cos theta plus sin theta is equals to root 2. That's what I'm given. Okay, how do we solve this? Just look at the equation. The solution is there in the equation only. The solution is there in the equation only. Sir, how? What do you mean by that? I am saying if you divide both sides, LHS and RHS both sides by 2. So if you divide LHS and RHS both sides by 2, what do we get? LHS and RHS both sides divided by 2. Root 3. I hope everybody is paying attention. Root 3 by 2 cos theta plus 1 by 2 sin theta is equals to root 2 by 2. That is 1 by root 2. Absolutely, Vijay. Excellent. That's really nice. With this root 3 by 2, either you write it in terms of cos or sine, whatever, it's perfectly fine. Let's write it in terms of sine. So sine 60 degree. So this is sine pi by 3. And that's cos theta. Similarly, this is cos 60 degree. So this is cos pi by 3 times sine theta is equals to 1 by root 2. Can I say 1 by root 2 is sine 45 degree, which is sine pi by 4. Correct me if I'm wrong. There is any doubt, please ask. Now, I hope you know sine A cos B plus cos A sine B. What is that? Sine A plus B. So this is sine A. What is A? Pi by 3 plus B, which is theta, is equals to sine pi by 4. Now, kindly let me know, did we not learn that if sine theta is equals to sine alpha, we did discuss that theta is given by n pi plus minus 1 to the power n alpha, the general solutions. Absolutely, Vijay. Very good. Keep it up. So theta is actually theta plus pi by 3. Alpha is pi by 4. So it will be n pi plus minus 1 to the power n alpha, which is pi by 4. So theta will be given by n pi plus minus 1 by n minus 1 to the power n pi by 4 minus pi by 3. And that is going to be the correct answer to this question. Everybody got this? Everybody understood it? Any queries or confusions if you have, please ask. Shall we move towards the next question, everyone? Give this question a try, all the participants. A very good, simple, direct, decent question. I'm starting a poll, so single choice, starting the poll. You can participate in this poll by downloading Pylons application from Google Play Store, or if you're watching it on your browser, Chrome Store, you can do it. Absolutely, Vijay, you can do it in terms of cos as well. Absolutely. With cos, you'll get a better answer. Very good. The answer which you have written possibly. So it says tan theta is minus 4 by 3. Then sin theta could be what? Okay. First of all, I don't know that tan theta is minus 4 by 3, which means which quadrant it could be. First of all, magnitude wise, of course, perpendicular and base. So hypotenuse will be 5. But sir, quadrant wise, I don't know. Tan theta is negative. So tan theta is negative in second quadrant or fourth quadrant. Yes or no? Yes or no? So I just don't know in which quadrant it is. Because in first quadrant, 10 is positive. In third quadrant, 10 is positive. But 10 is negative in second and fourth quadrant. So if theta is given to be Tan theta is given to be minus 4 by 3. My theta could be either in the second or fourth quadrant. Everybody process this idea. So if I'm asked about sine theta, magnitude-wise, it could be 4 by 5. Magnitude-wise, it could be 4 by 5. But sir, I don't know which quadrant it is. Because it could be either second quadrant or fourth quadrant. In second quadrant, sine is positive, but in fourth quadrant, sine is negative. So I don't know. Plus 4 by 5 or minus 4 by 5. So what will I say? But not 4 by 5, wrong. Option C is wrong. Option D is wrong. I'll say plus 4 by 5 or minus 4 by 5. Option B. Did you all mark it? Did you all get this? Everybody was able to do it. Nobody? No worries. Shall I move towards the next question, everyone? Did you all understand this result? Any confusions? Okay, there comes another question. I'm again starting a poll and I'll be hoping and expecting that you can write your answers. Even if you're writing your answers in the comments, it will fetch your answers from there and take it. So everybody give it a try. You all got a little late. Why? Here comes the next question, everyone. It is asking you the greatest value of sin x cos x. Amazing. Can something be easier than this? Sir, if you multiply sin x and cos x by 2, so I have to divide it by 2. So can you help me with sin x cos x with 2? Sir, that's sin 2x. So sin 2x by 2 it is. Sir, what we know in life is that sin, whatever you do, it always lies between minus 1 and 1. So if I divide it by 2, so I'm dividing all the sides by 2. So it will be from minus 1 by 2 to 1 by 2. So I'm saying sin 2x by 2 clearly lies between minus 1 by 2 to 1 by 2. What did they ask you? The greatest value. So the greatest value is 1 by 2. Option D. What's going on, students? I think there is again a mistake you're committing. The answer will be not 2. The answer will be 1 by 2. Don't you realize it? I think another few minutes, I'm almost done. The last set of questions we are doing, and then we are done. So option D, 1 by 2. Very much surprised I am. Not many of you marked correctly. No worries. Let us solve few more questions, everybody. Give it a try. This is again a very beautiful question. A very beautiful question it is. Sir, why are you saying very beautiful question? I am saying very beautiful question because it behaves like domino effect. One of our students in our paid batches have called this category of questions to be based on domino effect. So what is that? I'll demonstrate it. This is, pay attention everyone, I'll start a poll so that you can participate. If you genuinely know the answer, do let me know. So here I'm saying this is cos pi by 5. For a while, just to simplify my efforts, I'm saying cos pi by 5 is theta. Is that okay? So this is cos theta. This is cos 2 theta. This is cos 4 theta. Then the next thing is cos 8 theta. Correct me if I'm wrong. Right? So to solve this, what I do here is, if I multiply it by 2 sin theta. Sir, again, how can you do anything like that? I am doing because I'll divide it by. So if I'm multiplying it by something, I'll divide it by something. Things stay sorted. It takes options, Vijay. So A, B, C, D you type, Arpita. Vijay, A, B, C, D. Let's say for this question, let's say if you feel option B. So don't say 1 by 16. You say A, option A. If you think option A is correct, write A in the comments. I think it will pick up as far as I believe, or if it doesn't, then you will use Pylin's application. Use Pylin's application. Instead of 1, say A, B, C, D. I think it will pick. A, B, C, D you need to write, I think. So, sir, why did you really do it? I did it because I think something really good is happening here. Don't you think so? 2 sin theta cos theta. What is that, students? Sir, 2 sin theta cos theta. That is, can you help me with 2 sin theta cos theta? Sir, that is sin 2 theta. That is sin 2 theta. I am asking you to multiply and divide it by 2 one more time. So 2 if I introduce here, 1 more 2 I'll introduce here. So what is this? 2 sin 2 theta cos 2 theta. Can you help me with that? Sir, 2 sin 2 theta cos 2 theta is clearly sin 4 theta. So this will become sin 4 theta. So sir, again if I wish to multiply it by 2, I'll have to divide it by 2. So it is already 2 square, so it will become 2 cube, yes or no? Then 2 sine theta cos theta, what would that be? So that be sine 8 theta, yes or no? That will be sine 8 theta. So this will become sine 8 theta. Again I'm multiplying and dividing by 2. So this is already 2 cube. So this will become 2 to the power 4. So 2 sine theta cos theta is again what? Sir, it is sine 2 theta. So in that case, this will be sine 16 theta. It will be sine 16 theta in the numerator. So now what do we do? What was theta? Sir, pi by 5. So let me substitute that value this time. So if I could substitute that value, what happens here is sine 16 theta. So sine 16 pi by 5. 2 to the power 4 is clearly 1 by 16. So I'll just keep this 1 by 16 outside, and that sine theta is what? Sine pi by 5. Everyone comfortable with whatever I'm suggesting? One thing I'm doing here is 1 by 16 I'll keep like this. Sine 16 pi by 5. If 16 is divided by 5, 5 into 3. So can I say this can be written as 3 pi plus pi by 5? Can you see this happening over here? And this is sine pi by 5. How did I do it? 5 into 3, 15 plus 1, 16. So I hope that can be done. Yes or no? Yes or no? Everybody. Good, great, excellent. With this, I hope you do know that here we see that 0, pi, 2 pi, 3 pi. So 3 pi plus something. So 3 pi plus something will push you in the third quadrant. In the third quadrant, sign is negative. I hope you know that because 10 and quad are positive. So it will be 1 by 16 times minus of sine pi by 5 whole divided by sine pi by 5. Correct me if I'm wrong. So this and this are cancelled. You're left with minus 1. Minus 1 into 1 by 16 is minus 1 by 16. Option D should have been marked by most of you. I don't know whether you have done it or not. So option D, let's see how many of you have gotten. Option D, option D. Arpita has got an option D. Beautiful, Arpita. Excellent. That's brilliant. Some of you got option A. I don't know why. I hope you must have realized the mistake which you might have committed by now, right? So there we go with the final question. Here we have this question which I am giving you as a homework question, but I'll definitely give you the hint here for each of these. So 4 questions are there, 4 hints I'll give you, and then we'll be done. So 1, 2, 3, 4. For the first one, what is the hint? Sir, 1 minus cos x. Do you remember that? I'm really sorry. 1 minus cos x. Remember that it is 2 sine square x by 2. That's the hint. Use it. You will be done with this question. Sir, can you give one more hint? Okay. For sine x, do you remember it is 2 sine x by 2 cos x by 2. Trust me, you will get the answer. For the second one, 1 plus cos x, 1 minus cos x. Again, same hint. 1 plus cos x is 2 cos square x by 2. 1 minus cos x is 2 sine square x by 2. Just apply it, you will get the answer. For option C, I'll give you the same hint again. 1 plus cos x is 2 cos square x by 2. And for sine x, I'll say apply 2 sine x by 2 cos x by 2. You'll get the answer. Are you realizing same thing is happening time and again? This D is very beautiful. I'll share the approach. 1 can I write as sine square x by 2 plus cos square x by 2. And this is sine 2x, which I am willing to write. I think I'm really sorry. 1 I am writing as sine square x plus cos square x. This option D I am doing here. Pay attention, everyone. And sine 2x I am writing as 2 sine x cos x. Everyone, please pay attention. And there is an under root over it, which means power 1 by 2 is there. So this whole thing is raised to power 1 by 2. Now what I do next is, look at the beautiful thing happening over here. I hope everybody must have realized by now is that, sir, a square plus b square plus 2ab. What is that? A plus b whole square. So a plus b. What is a? A is sine x. What is b? Cos x whole raised to the power 2 raised to the power 1 by 2. So if you now think that 1 by 2 into r cancelled, you're wrong, you're mistaken, because we have already learnt it, haven't we? that under root over x square is not x, it is mod x. So the answer will be mod of sin x plus cos x. So for D, I can say answer will be 3. Rest, I have given you the hint. Any short method. Yes, we have learned that trick in the Arjuna batch. Don't you remember that? So what is the summary for today's session? Summary if you want. That's good, Vijay. You have already given the answers. Beautiful. Excellent. Excellent. Summary of today's session is we have done trigonometric functions. No, we have done trigonometric equations as well. So first part of this live was more of theory, where we have done a lot of theory, concepts, a lot of formulae with a lot of identities. Remember that? So that part will help you understanding this chapter. Then in the second part, we have done some questions. We have practiced some questions. So what are you supposed to do is, if you are really enrolling for this free batch, this is a free batch. If you really are enrolling for this free batch, this PDF you'll get for free. The link is given in the description. This entire PDF, which contains all the notes, all the formulae of trigonometric ratios. So this can be a Bible for you. Trigonometric functions, the whole chapter you can revise with this one PDF. Free batch. So sir, if we click on that link, we can enroll for the batch for free. Yes, not just that, you will get all the notes, and along with this, you get the 24/7 doubt support mechanism. You can get your doubts clarified anytime, anywhere, wherever you want, online. So that's the advantage. I am sure this session must have helped you a lot with whatever we have done so far. If you have any queries or concerns, please ask. Otherwise, we'll call it a day. So I hope it was helpful, understandable. You were able to get a lot out of this session. Shall we end it now? Any queries or concerns? So with this, I think we have given a decent clarity on this chapter, trigonometric functions. Let us meet in the next lecture with some more insights. Thank you so much. Stay tuned. Take a good care of yourself. You have been a great audience. Good night, everyone. Thank you so much.